No? Okay. Do it in person. Without the microphone. Okay, hi everyone. Welcome to the first Data Science Research Showcase. My name is Sebastian Link. This is James Curran from Statistics. And we've been running the data science programs at the University of Auckland. Actually started back in 2013 when we introduced the Master Program of Professional Studies for Data Science. And we've introduced a few more programs since then, so an academic master's, but also an undergraduate degree. And we've been growing ever since, so it's very fitting that we have a research showcase like this. So the aim is really to bring together people from different areas, but also people from industry, our students, and also academics. So we're very much looking forward to the event. I'd like to thank, of course, a few people. Foremost, Tanya Carter and Suzanne Cook, who put together this event. So without them, obviously, two professors would never have been able to pull that off. So they did really the hard work, just like in data science. They gathered all the people and they prepped the people, and of course we did the ironing of the t-shirts beforehand. So all the resources went into that, and now we do the analysis here, and then later on you have to tell the stories, right? So it's a real data science event. I'd also like to thank all the academics, all the students obviously, and of course all our industry organizations who have come together here today and support us. Especially I'd like to thank AWS and also Tower for putting some money up to run the event even better. Do you want to say a few more things?
Just very briefly, so welcome from me as well as from Sebastian. It's really great to see you all here today. We hope that this will be the first of many successful events of this type. Students, this is an opportunity for you to meet potential employers and industry people. This is a chance for you to meet our students and find out the interesting things that we've been up to. We see data science as being an integral part of the New Zealand science and industry scene for the foreseeable future, and we're really glad to have all of you as partners in this endeavour.
Cheers. So I think we want to all stay on time, so I invite Pieter Brown, our first speaker, to tell us a little bit about the value that doing the degree brought to her career. Pieter was actually the first graduate of the program, together with Jiva, back in, when was that? 2015 you graduated.
Sorry, Pieter, you're still young.
What is it, the full screen again? Shifty phone? The shifty phone? What's full screen again?
Control L.
Control L. There we go. It's not shifty. That mic's on. Okay. Kia ora koutou. Hi everyone, thanks for having me along to the first Data Science Research Day. I'm just going to share some of my experience studying data science and what I've been up to since. I actually went and had a look at the science building construction site walking in, and I started going there 20 years ago for Maths Olympiad training camps on the weekend, and 20 years later I'm still coming back, so very fond of Auckland University. So I joined in 2005 after high school, and I'd always had a passion for pure maths, and I wasn't really sure what else I was going to do. So I started studying psychology, I did anthropology, classics, English, and that was my first year and I absolutely loved it. And then in the second year I started to think a bit more about what I might want to do after university, and actually switched to doing science and law. So I kept up the pure maths and did a law degree, and during that time I started to become more excited about applications of data and moved more towards statistics, and did some really interesting summer research projects during my time here. So I looked at things like ICU bed capacity, I did a project on animal movement modelling, and it was really fascinating. And then 2011, I was doing my stats honours degree here, and I was looking at genetic expression data for my thesis, and I was sort of starting to hear more and more about big data, but a lot of that, I guess, for me was in a bioinformatics context or a web data context, and I found it really interesting and exciting, but I didn't have training as a computer scientist. I had done coding here, but it had mostly been in R throughout all my statistics papers, so I thought this is really interesting, but I didn't really have the skills to know where to get started, and I wasn't sure what was happening in New Zealand in that space. So I joined Kaggle, the platform many of you will be familiar with and will have used yourself, and I was entering competitions, and most of my time was just dealing with the frustrations of trying to set up a home laptop to do these kinds of data mining competitions, and the hours on getting a dual boot on my machine and things like that was just, hours of frustrations. And I'd never even used SQL at that time, so I really was starting off in a lot of this. But I managed to get through a lot of those challenges with computer setup and learning to code, and did more and more sort of online courses, teaching myself, and really thought this might be an area I'd like to get into, but didn't really know that there were job opportunities in that space in New Zealand, and thought it might still be some time away. So 2012, I was working as a graduate in management consulting, and that was really interesting, getting to apply, I guess, a lot of that analytical thinking training in real-world problem contexts, which is what I loved. And then this now infamous article came out that data science was going to be the sexiest job of the 21st century in the Harvard Business Review. And I took a paper while I was working in statistical data mining through the University of Auckland, and thought, I really do love this, and I'd like to move more towards this. And then in 2013, a few things happened. So an opportunity came up at a small Kiwi company called Datamine. They've actually been around for well over 20 years, so they were really, I guess, ahead of their time when they were doing database mining for personalised marketing for decades. And I joined them. My job title on my business card then was geek, and it was a very, very technical role. So SQL turns out to be most of what I was doing every day in, day out, working with databases across a lot of different industries. So I worked with insurance data, grocery data, lots of retail, and we did some amazing projects there. So some of the really theoretical concepts you might learn about, such as association rule mining and all these types of things, we were able to apply those with this really rich grocery data set, billions of grocery transactions. We were able to do things such as look at retail site placement using theories drawn from gravity and physics. So it was an amazing time to be starting to bring these ideas together on problems with New Zealand businesses. And I also became of Coursera and other online platforms at that time, so I was able to, I guess, start to supplement some of those gaps I felt I had in my own background, particularly in the computer science space. And then I saw the brochure for the Master of Professional Studies in Data Science, and I thought, that's absolutely what I want to do, but I want to keep working as well. So the next 2 years we're doing both of those things together. So 2013 and 2014 I did my Masters of Professional Studies in Data Science here. I put a little screenshot there of the courses that I chose. So they were really more focused on a lot of computer science and data mining, and I was really interested in these ideas around uncertainty in data and probabilistic data. And I did my master's thesis with Sebastian as my supervisor on probabilistic databases, in particular keys over probabilistic databases. And I was really lucky to be able to go to Sweden and present my research, and it was just a really fantastic 2 years of learning so much. So I graduated, that's our photo there, in 2015, and we got some really nice sort of press and comments at the time as the first graduates from this program. And I thought I'd talk a bit about what I've been doing since graduating. So in 2014, I joined Loyalty New Zealand, who run the Flybytes program. And my role then was as an insights manager. So that was essentially a translation role between our technical teams and our clients. And we were working across all of the Flyby's participant networks. At the time, there were over 40 participating businesses. So you can imagine how rich that is and how much opportunity there is for customer behavior profiling and understanding. We also learned a lot about the challenges of navigating, I guess, a data ecosystem with different partners. And the focus here was really on those ideas of behavioural modelling and prediction that we're so well aware of now. But back then, a lot of this was still quite new. So thinking about churn modelling or understanding customer behaviour profiles and things like personalised marketing. I think it also helped to set some reasonable expectations during that time. So going into that, a lot of leaders had this idea that big data was going to let you predict someone's behaviour with this just unbelievable accuracy, and you would, all the language about mining for gold and data and things like this. So there were these really inflated expectations at the time, and while we were able to deliver some real value, often it was just doing the simple things well with data and building in good metrics and good customer profiling. Then in 2016, I joined PwC, Pricewaterhouse, and they had recently acquired a design agency. And what they did was combined that design group, who had qualitative researchers, visual designers, engineers, as well as people with more of a, anthropology, human-centered design background. They put the data science team with that group, which I thought was really exciting. That's what drew me to join that team. And I thought this is something quite new, and I think this is what we need to be doing. So we need to be taking a much more human perspective to how we approach data science problems. And we were also looking at new ways of working with customers. So rather than taking a vague problem description, going away, doing all this work, coming back, inevitably most of it's wrong, and starting again, it was about how do we collaborate with clients and work differently. So one project that was a real highlight was a financial services project focused on customer retention. And what we did there was we set up a big physical space. We had a blended cross-functional team, and we would approach it in a real sort of hypothesis-driven way, drawing a lot from a book called Lean Analytics. And with our data science team, we would build a model quite rapidly, often in a couple of weeks. And we would actually be able to deploy that and test it because we had the right marketing people in the team or the right web developers. And by running experiments, we were actually able to do things that helped with the challenge we were looking at, which was customer retention. And we could actually prove some really measurable value from that program of work. So that was a real highlight for me. And that physical space became a really exciting hub as well for people to come in and learn about data science and grow interest in that within the business. And then in 2019, I joined where I am now, which is Orion Health. I'd always wanted to get into healthcare and had followed Orion, which is a Kiwi company, also over 20 years old, with a lot of interest since my early studies. And for those that don't know, Orion is a health technology software company, and our vision is about personalised medicine. So a lot of our products support that by working with electronic health records and serving that up to help patients and clinicians with care. So Kevin Ross, who's here, is our research director, and we also have a partnership called Precision Driven Health, where we focus on investing in data science research for New Zealand. My role at Orion, I'm a senior consultant, and I focus on working with clients to really implement and develop machine learning within their organisation. So that might be building a custom model, or it might be taking a model developed overseas and evaluating it on a New Zealand population, for example, or working with clinicians to see how do we actually embed that within their workflow. We've been hearing a lot over the last 4 years about responsible AI and AI ethics. A lot of that is quite high level and probably doesn't have a lot of teeth to actually help us implement it, but that's the space we're getting into now, where we're really looking at concrete guidance and practical ways to do this in a healthcare context, which I find really exciting. I wanted to make a comment here about women in data science in New Zealand. So I felt, looking at Lisa here in the front row, I felt really fortunate to be part of an amazing community in New Zealand from my studies right through to now. There's lots of women here in the audience where we meet regularly. There's some great communities and groups, so I encourage people looking for that to reach out to some of these communities. That's a screenshot from a panel there. I was talking at the Privacy Forum in 2016, and there's Rima Vaithanathan, who's an internationally known academic, and Liz McPherson, who is chief at Stats New Zealand. A little bit about what we've been up to this year. So 2020, like it has for many, for us, has been focused on supporting New Zealand's response to COVID-19. A big initiative that we've had is called the New Zealand Algorithm Hub. And this was an initiative supported by the Ministry of Business, Innovation and Employment to make a platform available as a central repository of models and algorithms for New Zealand and enable those to be easily used and integrated with. So we've been live for about 2 to 3 weeks now, algorithmhub.co.nz. You're welcome to go and check that out. And a real highlight of this project has been the governance process that we've taken those models and algorithms through. So we had an advisory board and we put together our own long form, algorithm documentation that we would complete for each model. And through that, we really learnt a lot and we evolved our process, and you can also access that template on the website if you'd like to take a look. 2 of the models available on the site were developed by Te Pūnaha Matatini, who many of you will know. A lot of the researchers are based here at Auckland University, and so part of our role was supporting the use of these disease spread and effects models for COVID-19. And acting as a data and technology partner, we were running those models that are deployed on the platform and producing a range of different outputs. So these included daily national reporting as well as weekly local reporting for district health boards and technical data for end users who wanted to incorporate that in their own processes. So for example, people looking at capacity planning could incorporate this into their own workflow. Just a few reflections and highlights on my study and my career since. I feel incredibly fortunate that I was able to take that early passion for maths and build a career that's let me work with really good people, do interesting and challenging work, and in areas where I think there's a positive impact for New Zealand. It's also afforded me the opportunity to travel internationally, comment on the radio, conferences, newspapers. I've been on governance and advisory boards. I've been able to mentor and do pro bono and volunteer work. So this year I was a reviewer for an international challenge called DataKind, which was looking at data innovation. So I also encourage you to have a look at them. I'm really excited about the opportunities for data science in New Zealand, particularly in the next 5 to 10 years. So I'd like to thank the University of Auckland and particularly Sebastian for being a great mentor throughout, and I wish you all the best with your data science studies. Thanks.
Okay, so next up we have an academic talk by Simon Urbanek. Simon has just recently joined the university from AT&T Labs in the States. Simon is very famous because he put R in the cloud. Essentially, so now we're hoping to make New Zealand the land of the long white R cloud. Great to have you here, Simon.
Thank you, Sebastian. So yes, as Sebastian was saying, I just joined the university this year, just in time. It's very close. I've been working at AT&T Labs in research for the last 15 years, and that was in the department of data science and AI research, which originally was called statistics department or big data research department. Kind of changed names over time as the buzzwords were kind of coming and going. But pretty much we've been doing what was today called the data science sort of from the beginning. So that's what I want to do is want to talk a little bit about sort of just going through a day of a data scientist or a project, data science project, a little bit about the concepts behind it and some little tools. And I'm sure we will have more talks about the tools later on. So what is data science in practice? So I'll just take one example, which was one of the early projects that I was working on, where what happens first is usually a business problem. It can be either a business problem or it can be an idea that you have that maybe how you can help someone. So it could be for greater good, for a town. We did some your urban planning and other things, but essentially you can just call it a business problem or an idea. So once you have that, in this case, the case I kind of want to talk about is just one example, which is we just launched a new product. It was voice over IP, one of these boxes where you can just hook up your old telephone, you plug it to the network, and you can make a call, right? So we can tell this is a couple of years back. And the question was, well, okay, we have a new product, and we want to detect fraud. So we define if people are abusing the system, not according to the rules how they're supposed to use it, and maybe causing us problems. Well, so the next step is, so on the left-hand side, I always have sort of the overarching concept, on the right-hand side, what actually happened. So the next thing is, well, define the task. So what do we need to do, right? So we have a new product and detect fraud. Well, what is fraud? So how do we define it? It's not that someone comes to you and says, okay, so you have a variable A and B, and you need to run a model and then give us a result, right? The way it works is more like, well, you figure it out, right? So what is fraud? Well, so you can start thinking, what could be a fraudulent use? You could read the use of the use terms or something, but no, that's probably not the good way. Really the good way is to get data. So if you're lucky and the company is well organized and, for example, dumps all the data that they have into one big data lake, then it's good because you can just request access. If that's not quite the case, which is probably very often the case, then it gets a little more complicated. So this can be quite a hard part of it, but let's say you get the data finally. Well, the next problem is the data has not been collected for the purpose of you solving this problem. This data has been collected as a side effect of something. Usually, like in this case, these were just logs from the machines that were serving the network. So, they just had lots of information, most of it irrelevant to our problem. So the next problem is, okay, so we need to extract the information that we need from this data and even look if it's available then. So that's the next step. And you need to look at different things. You need to see what is in there, try to pull out what could be useful. So probably some kind of timestamps would be nice, some kind of maybe stereo location information. Where is that box? Okay, so let's say an IP address would be something you could look at. What are the connections? What are the let's say phone numbers or countries involved and things like that. So you need to extract all of that. You need to look at it. It's not this is going to be pretty big. So if you're talking about millions potentially of devices, then you can't just look at all of it. You just need to look at certain patterns. So in this case, we just said, all right, let's extract at least some information that we can deal with. So then once you do that, you need to review your assumption and see if this is actually enough to get you started and actually solve the problem. So you need to see, is this information actually sufficient? Well, for example, if we're interested in things like people taking the box, traveling someplace around the world and then just plugging it someplace else and making a lot of calls, whether it's fraudulent or not is a question there, depending on what they do, then we would need somehow the location. Now, it's not going to be directly in the data, it's going to be indirectly. So now you need domain expertise. You need to know someone who actually knows how does this thing operate, how do I map the information that I have in the data to something that I can actually use. So in our case, we're looking at, let's say, timestamp, endpoints. So that's how we can get location. The next step is, well, we need to essentially figure out what's the normal use and then try to flag things that are not a normal use. In order to do that, we may want to sort of extract patterns and then compare the usage with those patterns. So that's where we get to modeling. Now, I started as a statistician. I also, like Piet, I started very theoretical in maths way back, but then kind of slowly moved all the way to very technical side of things. So this is what we like to do, but this is this little piece in here that's now finally you can actually build a model. You can try to predict or capture what is the normal behavior, whether it's seasonal or depending on location or customer cluster or whatever. But now you can do the fun stuff. Once you have that, meaning modeling what's the normal behavior, you can actually answer the question of, okay, what is not a normal behavior? What is the behavior that you want to flag potentially as fraudulent? So at this point, now we finally did all this, we actually need to present it to someone, because this is no help to us. We won't be able to act on this information. It will be someone else. So we need to present that information to people that will be actually dealing these things. And for example, they may need to drill down. It may not be sufficient to just say, oh, I think this is fraudulent. I may need to actually give people more tools, and then can say, okay, fine. So let's say this box makes a lot of calls for some reason. Is it a legitimate reason? Maybe it was some business using it. It's fine. But maybe someone just shipped it over to let's say to China or India, and now to set up a whole telephone exchange in front of it is charging people and using IP just to transfer this for free. So which of these cases now we need to actually talk to other people? So we need to report these anomalies and need to be able for the users to investigate. So in order for that to be useful, now we have a feedback loop. So I guess I forgot to mention, it's very important that we actually iterate through this process all the time. So the moment we get our ideas, let's say, what do we need to do? We go back and maybe we need to redefine the task. Maybe we need to redefine what we will be extracting from the data. And even as we build the models, maybe we find out something, new data sources we may want to pull in real life. But at this point, we finally have something where we want to build a prototype so that someone can actually use this. So these days, fortunately, it's much easier than it used to be. You can actually build a dashboard, let's say using Shiny or any of the other web technologies. And then the only next step is to deploy your work. So hopefully, if you're lucky, then that's going to work. So the final step is move to production. So you need to hand it off to someone who actually will run it, and you can go off and start with a new project. So that's sort of, let's say, a model, an attempt to describe sort of what is a lifetime of a project in the data science pipeline. So if we look at the whole process, there are all these pieces. There is the importing of data, cleaning, transformation, visualization, modeling, and then finally at the end there's the communication. And I find it really important that actually we include all of these. So some people may prefer just doing quantitative stuff, but no, you have to look at things first as well. If that's hard, that's not an excuse. You just have to find a way how to do it, ideally. And hopefully we can help with the tools. So, as I was saying, as a statistician, we kind of always started with this saying, okay, we want to build a model. And I was actually doing most of my thesis on visualization and model visualization and data visualization. So at least that's covered as well. So hopefully, the tools are being built for this more and more these days than they used to be. But then there is, the other side, which if you come from the computer science, you're probably going to be much more familiar with, which is all this transformation programming. And there are many, many different tools. So for the visualization modeling piece, as you can imagine, we were using R for pretty much everything there. For the cleaning, transformation, and so on, there is a whole set of tools depending on what your backend is, where your data comes from, and so on. You can use many different tools. Some of them will actually be mentioned later today. Us being the lab where Unix comes from, we've been using a lot of the Unix tools, but it pretty much doesn't really matter. It's all about the concepts, and you will learn the tools because they depend pretty much on what the company is using, what the data sources are using, and so on. And then at the end, we also have the communication. So you need to be able to communicate the results. You're not just going to throw someone the code. You have to actually talk to people in order to be able to do that iteration. Like Pieter was saying, it's important to actually involve the customers in the discussions because that will guide your models and your work. So, a lot of times we have Markdown, HTML, JavaScript, and so on. So, last piece. So this has been sort of shown before, but one piece I want to make here is it's ideally if you can combine this into one system, because, or at least some linked ecosystem that can be using different technologies but can kind of link them all together. And the reason is because you won't be the only one working on this, and you want to there are many other people who will be involved in this pipeline. So you need to communicate with them, and you need to share your work with them and make sure that if someone leaves, this thing doesn't break apart, so that it's still possible. And that's why collaboration, reuse, and reproducibility are actually very important, especially because these are usually not just one-off ad hoc analyses. It's something you want to move forward. So of course, there's many ways to do that, but what I want to do here is I want to talk a little bit about, as Sebastian was talking about, the R cloud, which was sort of our way where we realized we had this problem for a long time because we've been doing data analysis. And the way it usually worked is you work on one machine, you did your codes there, you pulled your data in there. 6 months later, someone came, that machine was gone, the scripts were lost, and it was really hard to actually replicate the research. So that's why we created R cloud, which was, the idea is pretty much just having a central repository of your work and decentral computing data sources and clusters. So that means you can tie these things all together, but you have just people that are collaborating on one platform. So everything is web-based, so there's one entry point that's just your web browser, and you can use it from anywhere. And then there can be a lot behind it, and I won't go into I have barely 5 minutes, probably much less than that even, so I won't go into these details. But I just want you to show this just a little bit. So, at a first glance, R cloud is just a console. You can pick your language of choice. You can use R, Python. In fact, we actually support anything that's supported by Jupyter because we can just run Jupyter kernels. But and at a high level, it's really just supports any kind of coding, including graphics. But one of the things is everything you do is version controlled, and you can see everyone else's work, and you can search for everyone else's work, and you can tie into many other systems. The other point about this is you can just click on a simple link, and it will give you a link that you can send to someone else, and they will just see your entire analysis, and they can do a deep dive. They can continue working with it because everything is Git based, so you can just do that. I'll just run, because I really don't have a lot of time. I just run simple examples of what you can do. They range from just regular, this would be something that I would go sort of step by step. If you run an analysis, you just start looking at different variables. You're trying to tease out some information. In this case, this is a taxi cab data set, so we're looking at things like tip amounts and so on. And this is just R in this case, but you can actually tie it into to interactive graphics as well. So in this case, here at the bottom, and because it's web-based, I can just actually change it. We're looking at different distributions using DC charts. So that allows us to drill down to things like, if we have some peaks here, you can see that, they kind of correspond to particular payment type, and sort of what's the distribution then of the actual total based on the range that you're looking at. So there's a lot of these things, and the whole idea is that everything that works on a web can be plugged in here. And to sort of make that point, that it's reasonably scalable as well, is I have one example here where I'm just loading all the cell tower locations from the entire world. This is a crowdsourced project, and this allows us to essentially do a visualization of all those towers. So we have, it's like 50 million data points, and you can see, it kind of makes sense where they are cell towers, there where are people, as well where there are roads, and obviously you can, the nice thing about this is that you can actually, if I get down here, I can zoom in and actually get to a micro level, just because all those points are actually loaded into the browser, and you can just use direct visualization techniques and so on. So this was just really very short sort of demo to show very tiny pieces of what you can do with it, just for the the industry folks. The nice thing about this, you can run it on a single laptop just for yourself. You can run it on bare metal machines if you want to support your own business. You can run it on clouds. You can run it on AWS. In fact, what I was using right now is actually running on Nectar, so our research cloud. So that's pretty much it. So thank you for your attention. I just wanted to sort of showcase a little bit about how important is it to actually have reuse and collaboration so that multiple people can work together and can leverage each other's code and share it all. So thank you.
Thank you very much, Simon. I think we're moving on to our industry presentations. So the first one is going to be a very sparkling presentation from Manish about Spark.
Right. Good afternoon, everyone. My name is Manish Kukreja. I did my master's in data science from this university. And now I'm working at Spark New Zealand, not to be confused with Apache Spark, although we do use Apache Spark as well. So the idea of this presentation is to just show you the importance of the other bit that Simon was talking about, where you hand over the model to someone, right? So we're going to explore a little bit about who that someone is and why is that important, and how we've done that at Spark, because we've been using a lot of machine learning models, and so what we want is a way of operationalizing them. So let's begin by asking a simple question, which is, what is AI? So I think most of you already know AI is the set of machines who become self-aware and start killing human beings, right? Well, that's a secret, an industry secret. Actually, AI is just nothing but complicated mathematical models running on these powerful computers, just so that we as humans can be predicted the next best cat video, right? Another industry secret. So for those who are not animal lovers, maybe you are nature lovers, you like more of trees and forest, you may be familiar with something like this, random forest and decision trees, I mean. So essentially it boils down to something like this, where you're trying to map the inputs to an output. Essentially you're trying to learn the relationship between the data. And why or how is this different from traditional software programming? Let's say you're trying to build a program which calculates the area of a circle. So to do that, what would you need? You would need maybe radius, you know, and you'd also need some sort of a formula, right? What's a data science presentation without some math, right? And so if you've got these two, you can pretty much plug that in and generate a area of circle. What machine learning does, it flips the paradigm where you now have input and output both at the input side of the model. So you have your area of circle as well as the radius provided to the model, and the model is trying to learn that relationship, it's trying to learn that formula. And the better it does, the more accurate it becomes. You can start publishing papers, writing dissertations, and maybe if you're lucky, you might get some awards, right? But that's not it, right? And that's where most of the academic sort of machine learning ends. But at industry, what Simon was talking about is more like an iterative loop, where it doesn't start with the data, it starts with a problem. And you often don't know what data to look for. So it's like a 6-stage process where it's loosely coupled. You often go back and forth with these 5 different stages. You look at, I don't think you can see. Okay. Hope now you can see. Yeah. So you start with business understanding, then you start with some data understanding, then you define what data structures or data tables you want to look for, do some modeling. Once your model is performing at a reasonable accuracy, you want to deploy it. And that's what I want to talk about. If we flatten the curve, meaning if we see that in linear approaches, we divide the machine learning into 2 different parts. We call it training and inference or production, right? So these are 2 different sets. Once we have a model, that's well and good, but now you have to hand it over to someone who needs to run this in a production environment. And why is that environment different than the building environment? Because you would be working on maybe millions of requests per second, just like what Google does. As soon as we type some keywords, you get the next best keyword in the search bar. And so it gets a lot of different requests per second. So what you need a different kind of a system. You need a highly scalable system. Also, you need a system which cannot be hacked, or it should be very secure so that the model is not manipulated. So these type of things require different sets of skills, right? But in industry, you often are asked, what is the best approach to deploy your own model? So what I'm trying to say is that most of the time we start with some data, we split it into train and test using Jupyter Notebook, we create a model, we publish the statistics, we create a dashboard, but that's not where the journey ends. In fact, after that, there is a lot more that goes on where you have to deploy that model in a production-ready environment so that the other applications can utilize the intelligence that you've built, right? So all well and good. Let's talk more about this second stage. But if we lived in a world where everything was in a vacuum, your model would just perform fine all the time. But as we all know, we are living in 2020. Life is not static. A lot of things are happening around us. People's behavior has changed. Events have canceled. Hopefully we have a T20 game today. So that's not going to cancel. Anyway, so if your model is running in a vacuum, it would perform better all the time, every time. But what this chart is showing that behaviors change, and we see something called a data drift. So once your data is drifting, what you need to do is you need to retrain your model. And so we have to go back, redo the first stage, and then do the second stage again. So it's not just creating model once, you have to create model again and again and again. So if you're familiar with something like DevOps, this is somewhere similar to what we call continuous integration, continuous development, where if you want to change something in your website, you do it continuously, iteratively, and that's what we have been more familiar now. Every time there's a new iPhone, it's just a little bit of change, and we get a new iPhone, right? And so that's what we mean by continuous integration, continuous deployment. It's just a few nuts and bolts you have to change, and then you get a new shiny product, right? And so when we have to do the retraining or even the training, the data scientists often download their data from some cloud, or maybe it's running in the cloud itself, these 4 or 5 stages. But then we have to talk to this guy now, who is sitting behind some wall in some dark place, maybe in China or India, right? Who's often, we just know them by the name or email address. So what we do as data scientists, we just send them an email, hey, can you deploy a model? And they're like very good person, they'll say, yeah, we'll do it. But when they look at the code, they're like, oh my God. It's all spaghetti, it's all Jupyter, there's no code version control. How do I deploy this? I mean, in the previous iteration, you were using one particular Python package, and now you're totally using a different language, Julia or R. How do I control your environment? So like these sort of questions often come into an engineer's mind. 5 years ago, I was in that place. I was an engineer. So I wanted to see what's behind this place, behind this wall where people start to grow their trees and forests. So I took a plane, came to New Zealand, learned data science. But sometimes it takes a lot of time just to deploy. It's not a linear process, as I was talking about, and it may take months and months. So as an enterprise, what you value the most can take a lot of time. Your experimentation could be good. You might get buy-in by showing some presentations, but you will never reach to a point where your model can be deployed. So from an industry perspective, what you need a lot more than what this diagram is showing you. It talks about iteration, it talks about iterative process, but it hides a lot of complexities. It doesn't talk about who does what, when. It also doesn't talk about the reproducibility, the governance, which is also very important. So I think which Simon touched about, that you should use some sort of a version control in your development environment, but also you need to talk about the model management, the asset management. So your model can now becomes a data product. How do you manage that? How do you build the trust and adopt it to the different technologies that are going to come in? So what I'm trying to say is that as a data scientist, you're not only required to have statistics, modeling skills, but you should also have some programming and engineering background, or at least some exposure. And also the new area that's coming up, which is ethics and governance and trust. And so IBM has created a few tools, which as a data scientist, we can just start using and create some metrics so that we can see how good our models are doing. And you might ask, but this is too much, right? And so that's the whole point, because when you go out in an industry, you see this is a zoo here. So you have to learn to navigate with different tools in different places. If you change jobs, like I changed from a university research software engineer to a healthcare data scientist, now to a telecom data scientist. So you have to navigate a lot between the different technologies, different tools. You should have these skills, at least not have them as a master, but at least be exposed to them. So let's talk about a little bit of how we are doing these things at Spark. What we are doing is we are using something called ML Ops maturity model. So at the moment, we grade ourselves as very basic, meaning we understand there are these two different stages. You create your model using some sort of offline database, and then once you have a model, you should have at least a registry where you're storing your model so that you can do model management. Once you have this stored, then you can serve it and run that in the production environment. Now this all happens very manual. You need to be very skilled with Bash and scripts because you have to interact with different servers and sometimes different environments altogether. So like you develop something on the cloud, but you're deploying on the prem. So what we do is we use a tool called MLflow, which has 3 different components. Experiment tracking, useful for running multiple experiments, and it shows you how good your experiments are doing with respect to various metrics, and also allows you to store plots like variable importance, shapely values. Then you have something called a model registry, in which where you store all the models. You can then put them into production, staging, or archive them. And then the third component, which is the ML projects, which encompasses the environment. So if you've got an Anaconda environment, then it is reproducible. It could be just used as a lift and shift project. So let me try to show you a quick demo of how we do these things. If I could just stop and slideshow. So what we have here is a GitLab repository where we store all our notebooks, which can allow us to train the models. So I'm opening the wrong notebook here. So this is our notebook, which creates the model, loads the data, and then runs an experiment. So once we have certain experiments, what we do is we log it on the MLflow. Once we put our data onto MLflow, so this is how MLflow looks like. It keeps tracks of all your experiments, when it was done, who did it, what sort of algorithm was used, and what were the metrics of it. And so you can select a few and then do a comparison, or you can drill down into one and look at different parameters. In fact, even look at different variable importance features as well. So once you are satisfied with a model, what you do then is you promote this model into, or push it into the registry. And this is where you can then do the model management. So once a model is in registry, you can change their status to production, staging, archiving. And so if the data is changing, if you're finding model drifts, you're retraining your model and you get a new version. And that's how you can manage multiple versions in production. So it's a very, very high level sort of demo. But what we want to do is we want to reach to this point. If I could just run the slideshow again. So we want to reach it to this stage where not only the model management is happening, but even the experimentations are orchestrated. They can be deployed onto the cloud sort of an environment. They can read the data from the data sources, generate the model, push it into the registry, and then deploy it in the production. And once they detect a concept drift, a trigger gets initiated, and it requires it to retrain the model again. And so what we want this to happen automatically. This is what the end goal is, and that's where the machines will become self-aware and will start killing humans again. And so, again, So what we are saying is at Spark, most of our models are now in the basic level where we have the registry where we can manage them. But we want to get into this place where we want to integrate it with the cloud and go on continuous integration, development, and continuous training. So that's it.
Do you guys have
Right?
Do you guys have any questions?
Yes.
Oh, yeah?
Regarding your website that you browse, why was it so many that are not secure? The website. With the green padlock, HT should be. HTTP.
Yeah, that's a good question. That's a really good question. The thing that that website is not HTTPS is because it's running off on our internal server. And so I'm connected to VPN now, and that's why I can show you this. Right. All right.
Okay, thank you, Anish. Okay, so next up is AWS, and Panesh Tripathi will present. So that's the last presentation before the first break. So after this, please grab some light lunch outside. And then we resume later on for another industry presentation, a panel, and then the student presentations. And if you guys still haven't had enough, you're more than welcome to join the industry advisory group meeting at the end. I think it starts at 4:30. So please use the time to mingle, talk to a lot of people that you don't normally get the chance to talk to, and just make the most out of it.
Epic. Thank you so much, Sebastian. One takeaway for me definitely from this one today is that I really need to up my PowerPoint game. Not gonna be as good as the previous speakers, just being honest up front there. So yep, super happy to be here again. I say again because I've also studied with Sebastian. He taught us uncertainty in data, and I did the same Master of Professional Studies in Data Science, worked as a data scientist in the research agency, which is a marketing research firm. Did some cool data science there. Then I worked at realestate.co.nz and finally got the opportunity to join Amazon, and super happy to be here. One of the key reasons as to why I did make all of those transitions and kept on moving from one job to another. So I just graduated 2 years ago, and the reason as to why I jumped so much is because I like challenges when they're big, and I want them to always be big. And I like those problems of scale, and that is what I'm going to be talking about today. So it's fun when you have a phone, but it's not so much fun for somebody who would have to handle 1 billion phones. And imagine now with over more cell phones and technology and connected devices than people on this planet, like somebody has to manage the back-end infrastructure of all of that. And that's the kind of challenges and problems I was super curious about from the beginning. So we will talk about this a little bit. Also, we do have a stall outside, so any questions that you have, either we can do them at the end of the presentation, or we can take them to the stall. The reason as to why I say that let's take them outside is because I have 15 minutes. There are over 30 AWS services for machine learning alone. Even if I give you an elevator pitch for all of them, like it's gonna be over time. So, yep. So these are some of the numbers that IDC, Gartner, Deloitte, and all the independent researchers have come up with. So by 2021, for instance, the global spending for ML and machine learning and AI is going to cross 50 billion USD. And that's just a number. And these have always been overblown as well. So these are conservative estimates that they think we are going to achieve. But as we'll see in the next slide alone, there are quite a bit of devices and machine learning happening that have already crossed those numbers. A lot more than crossed, actually. So with 4,000 products being sold every minute on Amazon, and every time you visit that website, it's like, people who bought this also bought this other thing worth $50. Would you really not want this at $50? That kind of personalized recommendations at scale, at that scale, when millions of people are hitting your website, or 1.6 million packages being delivered every day, or billions of Alexa interactions each week. Now that is astounding to me because I have 7 Echo devices in my home. I listen to music everywhere, and I literally say like, Alexa, play music everywhere. And then it's just everywhere, and I love that experience. It's with microsecond latency and concurrency within all of those systems. So when you move from one room to another, you do not feel like you've switched a speaker. And in order to accomplish that, you have to be able to stream to all of those 7 devices. In my case, there may be somebody with 700, I don't know. But in order to accomplish that, like, you have to be able to asynchronously and concurrently be able to stream audio across all of those devices. How am I doing with time? Badly. So yep, first Prime Air delivery on 2016. Some of the customers that we have, you will, like, that slide, I don't get it. Like, we always have it there because we want to talk about our customers more than we want to talk about ourselves. But it's very tiny. But a few recognizable ones, I think, maybe that you can see. This one, most university students are familiar with. There's, of course, Formula One. There's NFL somewhere. NFL we'll be talking about in detail. Yelp, Kia, Pinterest, Domino's, and whatnot. So every major thing that you can think about, including Netflix, Spotify, Amazon Prime, of course, and every other thing. And the reason is simple. Because when you're starting out building a product for millions of customers in mind, when you're starting out, and of course Orion Health as well, so glad to have you here. When you're starting to build a product that you know could scale to millions of people, you need somebody with that kind of capacity. You need your infrastructure provider or your platform that you're choosing to have that much capacity that they would scale out to that many people. And we will see some very great customer stories who scaled out significantly in that time. Oh yeah, also, I do realize that I should have also brought in some of my outstanding achievement certifications, like Manish did. That adds more weight to the conversation, I think. Otherwise, it's just some guy who graduated. Like, I got one in Sebastian's course as well, so that was fun. Yep. Oh, yep. So.
At an audience level, we ignore the certifications.
You do? Oh. Whew. So yes. Again, as I said, 250 new features and services. Can't even name them all in 15 minutes. So super happy to talk about all of this outside though. So there's a ton of cool stuff that has come out day before yesterday. On 24th, we did 48 product and service releases. And there's tons coming next week with reInvent. So super happy to chat about all of those. When we think about AWS, about machine learning at AWS, we think of it in 3 categories. And the chances are, if you are a student, may I get a show of hands for how many students are in this room? Yep, awesome. Great to know that, because you will be joining some organization which would roughly fit in one of these 3 categories. So the first one is who's just starting in their AI journey, who do not have any data scientist experience or machine learning engineers at the moment. You're the first ones. And you would be expected, as Manish said, like, or as Peter said, like, the expectations are there. Like, give me a magic wand and show me what the results are. Like, give me AI out of the box right now. And for that kind of customers, and this happens at like the biggest to the smallest of organizations, for those customers who want to use and leverage machine learning but don't yet have the expertise, there's the top level, which is AI as a service. So you can plug into Amazon Kendra and start searching text documents without having to know anything about natural language processing. Or you give Amazon TextTrack a piece of paper, it will scan all the text in it with by word, by paragraph, by line, and give results back to you. You don't have to know machine learning in order to use those. And that is out of the box things that you can start leveraging, and tons of our customers do. So you might have heard of this company called Intuit, which makes QuickBooks and TurboTax. Somebody is familiar with the US's tax system, which is quite intricate. So yes, so they are a customer who use TextTrack heavily. Then there's, of course, the things that Manish talked about as well. Productionizing the machine learning. So when you've built a model, you really need to put it into production for somebody to be able to use it. To the point where it's an API endpoint that somebody calls with a particular data point, and you give it an inference back. In order to be able to accomplish that entire pipeline that was, again, PowerPoint game beating me to it, that entire pipeline that he showed where you collect data, you do some analysis on it, you do experimentation, you run multiple models, you compare the results, you visualize them, and then choose one model that you would deploy into production. That entire pipeline is taken on by this middle layer called SageMaker Studio, also available in Sydney region now. And then there's companies who are super advanced. So these would be the Data Minds and the Orion Healths, and the companies who've got well-established machine learning practices are very comfortable running their own infrastructure, where we give them in one instances. So dedicated custom risk-based ARM architectures that you can build your infrastructure upon. So you have dedicated instances for inference, dedicated instances powered by GPUs for training, and these would be like the better and more sophisticated machine learning organizations. So I already did talk about this. Let's talk about this. This is fun. So 3+ terabytes of data is the amount that NFL generates in a week, and 1,500+ hours of playtime. Now that's the scale that excites me very much, and that's why I enjoy doing what I do. So I'm currently, I totally forgot to introduce myself as well. I'm terrible. I'm doing terribly at this. I'm a solutions architect with AWS. I specialize in machine learning and AI services, and I work with our customers here in New Zealand. We are based out of Vineyard Quarter, Auckland, and yeah, I help New Zealand customers to build sophisticated machine learning practices and go beyond. And totally lost that slide. Yes. So they did not have a lot of machine learning expertise. They engaged with the AWS ML Solutions Lab. And as you can see, there's quite a bit happening there. And in the end, the product that they built did 100 steps of pre-processing, created an inference in under a second to give their customers real-time statistics and keep the fans engaged. Now, that speed at that scale is what AWS brings to the table. And that is what we offer, and that is why we do what we do. Because sometimes it becomes necessary. Another case study, which I don't have on slides here, but you can look it up, is Formula One. So Formula One, again, as the cars move, as they make those split-second decisions based upon how much the car weighs currently, where is the center of mass, and over 200 sensors that are in every Formula One car, they make split-second decision-based inferences as to why the driver did what he did when he did, and display that in real time. So that is powered by AWS as well. It's a great case study. I encourage you to go and read it online. This is some of the architecture that unfortunately we don't have the time to get into. I will and can make this slideshow public if somebody wants it. Like, feel free to mail me. My email address is everywhere, including the desk outside. So that's definitely there. What else can we talk about? So again, as I was saying, how much time do I have left? 5 minutes? 3 minutes? 4 minutes? Am I comfortable?
You're out of time, basically, but
Oh!
go for it.
Oh, okay. So Amazon Kendra, as I was saying before, enterprise level text search without having to do machine learning and AI by yourself. Oh, I started 5 minutes late as well, Sebastian. So I think maybe 2 minutes more. Just 2 minutes.
Whatever you need.
Thank you. That's what he said for my thesis as well. So thanks for that as well. Automating online fraud detection. So one of the things that we also offer is called Amazon Fraud Detector, which can detect anomalies based upon the previous data that you give it, and you still don't have to know machine learning for it. So let's say you have been collecting data for the past 20 years, detecting anomalies and fraud orders if you're an online shopping company. You can give all of that to Amazon Fraud Detector. We'll do transfer learning in the back end without telling you what it exactly is. But we'll give you a model endpoint where you can send your new transaction, start hitting it, and know whether it's a fraudulent transaction or not, without knowing any machine learning. So that becomes very relevant for companies like GoDaddy, again, who use that extensively. Or CodeGuru, which does profiling, machine learning powered profiling on code to find out things that are not performing as efficiently as they should. So sections of your code which aren't written well, so that there's no spaghetti code in your production environment. Does that automatically. And Atlassian uses it. Might have heard of them. Bitbucket, Jira, Confluence, and all of these products are Atlassian. Based out of Australia, amazing company. Again, a slide from marketing team. So that's epic, true, and again, like we're so short on time, so apologies for running away. But yep, You can visit that website, by the way. It's an actual website. Any questions? Yes, please.
I wanted to ask that how much is the investment to profit kind of comparison? And how much does NFL invest in AWS and how much profit did it gain out of that?
Oh, so that maybe would be a better question for NFL. I'm not sure I can comment on that. Although what I can tell you is most AWS services have a free tier. So if you're doing a project or if you're working on something that you need machine learning for, you can start using the services within their free tier, and it's literally like free as long as you stay within those limits. So that includes text, track, comprehend, and a lot of them have perpetual free tier as well. So as long as you're alive and you have an account, you'll have free tier on those services. Yes, please.
When were you bringing your data centers to
I wish they told me that. They don't. Like that's something I have no comments to make on that one. But when we do, there will be an announcement in post, like we did for the CloudFront POP, which is now live in Auckland. Yes.
So what if someone use, for example, Tor, T-O-R,
T-O-R, yes.
You know that one? Can your fault detection still work if somebody use a Tails, Linux, or Qt, and then with the Tor?
Yeah. So that's a great question. So the question is, if somebody uses Tor or some kind of VPN method to bypass the traditional means of accessing a particular website and doing something malicious, can the fraud detection system still detect it? That's a great question, and the answer would lie in how good your data set is. So how sophisticated is the data set that you're originally using to train the model itself? So if you've got like 20 years of very rich data where you've meticulously identified and noted that, yep, this was a fraudulent transaction, absolutely, like that data will be used to train the model and that would come up. But that is true for pretty much any machine learning problem. So in order to identify something that's, as you said, like a Tor based or something that's out of the box, like yes, if the data set is good enough, you will be able to identify that, absolutely. Any other
Thank you very
questions?
much.
Yes, thank you.
So I suggest we have a light lunch break, and then we can resume at 2:30 with a presentation from eRoad by Gareth Roberts. left from E-Road. So it's our pleasure to welcome Gareth Robbins. So E-Road's been one of the big supporters of the data science program. They've actually hired quite a few of our students, and Gareth is working with it.
Yeah, thanks very much, Sebastian. So I was just saying that I'm not a graduate of Sebastian's course, the only one, but I'm surrounded by very smart people who are, and I'm very happy to work with them every single day. So I'm Gareth Robbins, the Director of Analytics for E-Road. I'm going to talk to you about trucks. So a little bit different. There is a little bit of machine learning in there that we do as I talk about some of the work that we do with governments and regulatory authorities and universities. So first I'll talk a little bit about what E-Road is. E-Road is a regulatory telematics company. We realise that there are some burdens on our customers in their day-to-day operations that can benefit from technology. So things like buying road user charges in New Zealand, managing fatigue in North America, paying fringe benefit tax, things like that in Australia. And we came about by creating a GPS-based cellular connection to trucks to enable distance tracking and purchasing of road user charges back in New Zealand about 2009. And since then we've expanded into a lot of other different areas. We see the same sort of issues in every single country. So the government has to worry about how to pay for the roads. Trucks have to worry about how to manage their fleets. How do we improve the safety on the roads? Companies have to worry about how to maintain safety of their drivers. And E-Road kind of fits into this little system here by applying technology to these regulatory burdens. So this is an example of this. So on the left-hand side, you've got the RUC labels that you might see in the front of trucks. E-Road designed and built this device in the middle called the eHubbo, and that tracks where the vehicle goes around the country, and it sends back data, and we use that data to then provide products and services and look at how the roads are being used. So in terms of the products and services for our customers, it's fleet management things, it's the regulatory solutions, it's understanding which vehicles are more utilised than others, which drivers are driving better than others, and really helping them be more efficient trucking companies. What I'm going to talk more about today is actually the bottom side, which is out of all of this data, how can we use that to inform governments and road controlling authorities on how the roads are actually being driven on? And how can we do that safely in an anonymised and aggregated way so that the customer's data is protected? That data looks a little bit like this. So we have events coming from these devices. There's over 110,000 of these installed in vehicles around the world. We suck in over 1,300 events every second, and each one of those events is checked and geocoded and tagged and stored and then fits into various data pipelines depending on what the product is. So all of this is on Amazon. It all just works, so thanks Amazon. There's about 14 million trips every month and about a terabyte of data every month. So a lot of what we do is kind of needle in a haystack type of stuff. So our system was designed for regulatory telematics, and everything that we're doing outside of that with the anonymized aggregated work is, understanding how those events can be changed and aggregated and combined with other data to make new data products. We didn't design E-Road for that system, but it's a byproduct of that. So a lot of work is really in cleaning and exploring and finding those little needles in all of that data. The reason why we do this is it goes back to E-Road's purpose. So we truly believe that every community deserves safer and more productive roads. It's what gets me out of bed every day, that I think that the work that we do can actually lead to saving even a single life. New Zealand has a very bad road safety record when compared to other members of the OECD. I think there was 273 deaths last year. So even if we can take a few of those out by using technology, that's something that is worth doing. And because eRoad has so much data, we almost feel obligated that we need to do this type of work. So we set about trying to understand what the transportation analytics industry is all about. This is a bit messy, but we have a number of different players in the industry that look for data. So everywhere from NZTA to ministry to local councils to universities to trucking companies, they all need data, and they all need road data. The problem is there's lots of data out there, but you can't always use it. You know, you've got to move it from place to place, and you've got to combine it with other things, and then you've got to worry about the minefield of people that are creating those really cool data types like LiDAR and, you know, UAV video and all that sort of stuff. So we thought that we could, we figure out where eRoad sort of fits into that. So we have this idea of, you know, the coverage versus the context of all of these data types. So you have cell phone data, which is, you know, everywhere. Everyone's got a cell phone. You can collect all that data, but you don't really have any context. You don't know what vehicle it's in. You don't know who's carrying it. You know nothing about that ping. It's just a lot of it. On the other side of the spectrum, you've got surveys and LiDAR, but you can get a lot of context out of those, but they can only happen in a few places. It's too expensive. So all of this data really has to be fused together, and GPS data is one of the data types that can help connect the dots between all of the existing data that's connected in the transportation industry. And we think eRoad is a little bit better than GPS data, obviously. So some of the things that we've been doing is trying to understand how trucks and cars are using Auckland roads and New Zealand roads with things like virtual loop counts. So you can draw a line on a map and then in near real time figure out how many trips go across that little line, what's the makeup of the vehicles that go over that line, where did they come from, where are they going to go, and then from that you can start building predictions of, you know, if we did something to this road, this is what's going to be impacted downstream. Looking at things like dwell time, so this helps with understanding traffic light phasing. If you see build-ups in a city of trucks waiting at traffic lights, that's an opportunity to tweak the phasing and get a little bit better. But I'm going to go into more of an interactive thing, which is more fun. So one of the things that we started with was actually crash prediction. So because of the really bad safety record that New Zealand had, we thought that we could use the eRoad harsh braking data to supplement the crash analysis system data and see if there were areas of the country where, you know, we could predict a crash before it happened. So the crash analysis system data is pretty rich. It's widely studied in terms of understanding crashes. The harsh braking data that we have is about 600 times bigger than the crash data. So it makes sense to study harsh braking as a precursor to crashes. So we looked really at the correlation between the two. So this was the intersection up at Silverdale. It's facing the wrong way, just to disorient yourself. I don't know why I did that. This is 5 years worth of crashes at this intersection, and this is 1 month's worth of harsh braking data at that intersection. So when we study these, we already see a lot of spatial correlation between the two. So what we did to take this to the next step is then apply this to the entire country and find the features of the harsh braking clusters that we can identify and see what features match or see what clusters match spatially with crash clusters. And we found about 101 areas of the country where we see harsh braking clusters happening, but not enough crashes. That's a good thing, but we think that there may be more crashes. So then the opportunity then is to work directly with road controlling authorities and say, you know, what small interventions can we put in place, signage or education or flashing lights, to say, you know, something's going to happen at this intersection. There's maybe traffic coming from an area that you can't see very clearly, or maybe people are turning right on a road without waiting for enough gap in the traffic. We also applied this to curves. So we look at curves around the country, and we are able to identify the most at-risk curves. So this is really based on the outlier detection of population curve speeds. So curves do have a speed limit, but it's an advisory speed limit, and it's not based on the right speed for every single vehicle. So a lot of vehicles are able to exceed that curve advisory speed limit quite safely. But what we do is we first identify where the curves are, because they're not really named. So we use the event data to work out where the curves are, define a population for that curve, then define some parameters for normal behavior, and then we can start to see as people exceed that. And when you put this into a real-time type environment, you can start seeing exactly when curves just get misused or get used outside of their normal parameters. And a lot of this is way past the design specifications of the curves. So those curves were not necessarily built with every situation in mind. And we find that New Zealand roads are used for whatever purpose they need to be used for. And you know, we see some situations where a road is not necessarily designed for a lot of forestry vehicles, but there happens to be a forest upstream, and that's been harvested, and now all those vehicles are having to go down this really tight, windy strip of road. So it really helps the road controlling authorities to understand pavement design, curve design, advisory speeds, whether there's interventions that need to be put in place for that. As I mentioned before, looking at efficiency, so this is the dwell time in Wellington, and you can start to see build-up of heavy vehicles at traffic lights. So this has implications for some of the ESG reporting that we do around the fuel burn of vehicles and the potential particulates that are going into the air, and it really helps Wellington to understand how to move vehicles through the city efficiently. Another piece of work we do is some of this ad hoc work that road controlling authorities have. So Hamilton had, you can actually see it at the bottom there, there's a gap in the traces of vehicles where the bridge was taken out for a new overpass on the rail line there. So it was one of the biggest detours that Hamilton put in place, and they asked us to determine if the detour was effective or not. So what that meant is first understanding what normal meant for Hamilton's traffic, because it does change all the time, and then determining whether people are following normal patterns or whether they're choosing different patterns, and whether that detour was actually the reason why they chose all of those different patterns, or if it was something else going on. Down in Kaikoura, when we had the earthquake a wee while ago now, there was concern at a lot of these one-way bridges were not fit to carry the 14-fold increase in heavy vehicle traffic that the detour route experienced. So we looked at the harsh braking that occurred along these detour routes, and we found a lot of these harsh braking clusters. So in this case, vehicles were coming down the road, they had right of way over the bridge, but the bridge itself was obscured. And when they would go around the corner, there would be another car on the bridge, so they'd have to slam on the brakes. So this led to not only better signage from NZTA, just finding this behaviour in the data, but also the idea of identifying these in more real time and alerting other devices that are approaching that area ahead of time. So as vehicles are coming down the road, and saying to them, look, we think something's coming up, you better slow down, you better watch out. Typically the data, you may have seen loop data on one of the previous slides. Loop data is used in the transportation industry just constantly. So you put a little rubber strip over the road and it just counts things. They're not very smart, they break all the time, they cost a lot of money to put out, you have to close the road down twice. But they're necessary. It's the only way to really count all of the traffic. The problem is it doesn't really give you any context. It it's a little puff of air and it says something went over me. Some of them are a bit smart, inductive loops, and they can tell the type of vehicle, the body of the vehicle that was going over, but they don't really know what happens once the vehicle has gone over. So the GPS data can kind of fill in those gaps. So if you want to know how vehicles go from Auckland to Tauranga, it's not just enough knowing that this many vehicles left Auckland and this many got into Tauranga. You want to know how they got there as well. And also, where can you put loops on the road so that you are going to get more of that population? So this is another bit of work that we do is trying to understand the loop avoidance of trucks. Not that they're trying to avoid loops, but they will choose the roads that they need to go on. And we can then tell which roads are best to put loops on to get that full population count. Some work we're doing actually with in Auckland, not in Tauranga, is looking at the risk of bridge or emergency maintenance on bridges. So in Auckland there's about 1,300 bridges that are monitored, and bridges and culverts, and heavy vehicles will go over them if they need to. And there is a risk of the cumulative effect of that weight going over, especially if the bridge or the culvert serves a new construction zone that perhaps hasn't been identified ahead of time. So we look at weight damage indicators to determine the likelihood of damage that's going to occur, and we marry that up with the actual way that the road was made and the decisions that were made to indicate what the risk is to that bridge. I think we actually do that. So we do this nationwide as well. This is Hamilton. The darker spots are where more weight is going over the network. So the goal of this is to then identify areas that we might need to send out better detection equipment to determine if there's cracks in that road or if there's any road roughness and what have you. And that's pretty much it. So I'm really quick. What we're trying to work towards is getting smaller questions asked of our data more rapidly. So you have all of those people that you saw at the start. They're all sitting at their desk asking these little tiny questions. How many trucks turn right into this commercial area? Because do I need to put a median barrier up to prevent that from happening? And there's thousands of these little tiny questions that can be answered with GPS data. But quite often it needs a big RFP, or it needs a big project, or it has to be turned into something larger to get access to that data. So we want to try and avoid that. We want to try and get the people that have those problems more directly involved in the data that we have, and us building the tools that enable them to ask those questions really, really quickly. So that's it, but I thought we might have some questions. So thanks.
I'd like to ask, the black curl lines that you see on some main roads, such as Great South Road, is that part of the tool that you...
I'm sorry, I didn't hear the first part.
It's like two parallel black lines that are put on roads.
Yeah.
In Auckland. Is that a tool that eRoad is using to collect data?
This one?
I think those are just the loops.
Oh, the loops. No. So loops are used by councils and NZTA, AT, everyone, just to survey traffic. So you will drive over them, look for them on the road. They're just, yeah.
Right, so
but we don't put those out. No.
Right. So eRoad wouldn't be analysing these data.
We do take the loop data that is publicly available. So we use NZTA's loop counts that they make available, and we line that up with eRoad data to determine what our statistical significance is. Because even though we've got about 85,000 vehicles driving around New Zealand, they're not driving everywhere all the time. So if we do some work in Invercargill, for example, we need to know how relevant that work is to the population. So we do use the NZTA data for that. Yeah.
That data is available as an open source in NZTA website, all the traffic count data for the whole country.
Yeah. Nice plug vacation.
Recently made available.
How do you get access to the hash breaker? Do you tap into the CAN bus, or is it just your device?
So right now it's just accelerated data, but we do tap into the CAN for other things. So there's a really rich data set in the CAN, everything from from vehicle steering wheel position to brake pedal position, things like that. We do have a camera technology that we're launching as well, so that gives us new opportunities to look outside and understand, the decisions that are being made with the environment that the person's in. So there's a whole bunch of machine learning that can be done and computer vision that can be done on top of that, and deploying those models to the edge to calculate that data. Yeah.
Have you heard of any talk in New Zealand to use drones?
Drones. Oh, there was an idea. Yeah, there was somebody who was talking about. You mean for telematics, or?
Yeah, for example.
Yeah, somebody was mentioning that. I think at one of the ITS conferences.
We have used it in a few intersections as a trial here to count traffic, to count cycles, to count that dangerous behavior. When cycles are approaching cars and cars have to do the harsh braking.
I think I put drones on here. I think we had drones was one of these things that that kind of has a lot of context, but it's still expensive to get coverage. So in some areas they're pretty good. You can get that video footage. You just have to cycle them up and down every 20 minutes because they run out of battery. Yeah.
Okay, thanks.
All right, thanks.
Alright, so next we thought we'd have a little panel. So can I ask all the panel members to come to the front?
Fire and squad.
Huh?
Fire and squad. Oops, we need a fake fire.
And we will be using a very sophisticated microphone.
I've lost my
So the panel itself is about education of the future of the data science education in New Zealand. So I will ask the panel members here to introduce themselves and perhaps say a few words about their interest in education and data science. Drew, we'll start with you.
Hi everyone, I'm Drew Watt. I have a nearly 30-year career in technology, which shows my age. So last 4 years I've been doing consulting and startups, but before that I was a chief technologist for IBM New Zealand. And I think part of my interest in why I've always supported the work that university does is just industry just needs so many people to do really interesting things, and it's just I had a great education at Auckland University, loved it, and all my degrees are from here, so it's really about trying to bring people up on that journey, and hopefully they can have as enriching a career as I've had over the years.
Hi, I'm Gareth Robbins. So I was at University of Auckland studying pharmacology, of all things. Very, very long time ago, but my interest in data science is the types of problems that can be solved by just thinking a little bit differently and using data and some structured approaches to kind of pull something out of nothing. It sometimes feels like magic. The thing I love about the university forum is that it is bringing so many more people and putting so much more credence to this discipline that I kind of taught myself the little bits of things that I know, and I'm just constantly amazed at what the new graduates know just coming fresh out of university. It's fantastic. So my goal is to really learn from all of these people and try and improve myself, but also impart some of the real world knowledge that I've just collected over the years, just by trial and error and luck, I think.
Kia ora koutou, my name is Kevin Ross. I'm currently head of an organisation called Precision Driven Health, which is a data science partnership in the health sector. So we do collaborations between universities, district health boards and IT companies, basically building data science models and tools. You heard from Pierre earlier, who's one of our lead data scientists on some of our work out of our own health. My background, I didn't study at the University of Auckland, sorry. I was at Canterbury. I did maths and statistics at the University of Canterbury, and then I went over to the States and did a PhD at Stanford in management science and engineering. So that was a bit before anyone called anything data science. It was one of the few programs that now sort of uses that label a little bit, but it was actually more equivalent to what would be called engineering science here at the University of Auckland, so operations research. From there I went to a bit of a combination career as an academic for a while, a consultant, and then returned home to New Zealand, first of all to head up analytics at Fonterra. So we looked at a lot of how might we use data more effectively in the primary sector, particularly in dairy. And then moved over to Orion Health and then Precision Driven Health about 4 or 5 years ago. So lots of interest in the education field. I've been obviously research and teaching in there. I lead lots of collaborations. I guess one opening comment is I'm glad that the audience out there is more diverse than what you see here, because that is one of the things that hasn't been great over the years of any sort of technical engineering field. And one of the things about data science, like a lot of these kind of emerging fields, is it really helps to have a whole lot of sort of different perspectives and education. And some of the reasons for success has actually been that it almost wasn't such a regimented, tight program that everyone came from that got into data science. Was sort of brought together, sort of hacked together teams of different groups. Has actually been one of the reasons why we've had lots of emerging opportunities. So I guess that's hopefully comments on that.
Thank you. Yeah, Sebastian Link, and you've already heard enough from me.
Good crack at you, my name is Paul Troy. I think that as you can see, we are not young people. So the reason why, I started at Auckland University, but I finished at AUT. So the reason why I believe and I'm involved in the curriculum development and so on and so forth, essentially it's not a joke. It's like, I'm an old man. I had a lot of good people helping me in and out of the academia. I have been in and out doing industry back to the academia and going back. And I think that is my responsibility as an old man and as an industry member to participate and bring that knowledge together.
So James Curran, I'm a statistician. I lead the statistics department. My interest is primarily in selling degrees. If any university doesn't say that to you, then they're lying. We are a business and we have something to do. But perhaps more altruistically or whatever, I'm personally interested in strengthening New Zealand's science and New Zealand's knowledge economy and breaking down the barriers between the universities and industry and our science institutions. We're a small country, we don't have many resources. This is a discipline that does not rely on a huge amount of resource, just brain power, and we've got plenty of that here, and that's what we're interested in developing.
Cool, thanks everyone. So just to say, this should be an interactive panel, so we invite questions also from you guys. And to kick things off, so this program has been running for a while, and what I particularly enjoy about the program is that it really brings together different perspectives, as the other people have already basically said before. So especially during dissertation projects where the students can, instead of doing a normal academic dissertation, can also opt for an industry-based project. So they get a mentor from the industry partner, they get an academic supervisor that together as a team work on a project, and then you can see the knowledge transfer from what's known in academia and how to contextualize in a specific business context, and therefore also the academics can also learn again what are the real world constraints under which the methods can actually be applied. So it's really a spiral, and it should be an upward spiral. Right, so that's really the main purpose also of the program, to do that. So the first big question is, how can we improve on that? Right, so we can do things at the moment as they are, but of course we want to do things better. So my first question, first to the panel members, would be how can we improve the current state of the art and make things better, particularly for students who enter the job market? Who wants to start?
To be honest, I need to say that you are doing a wonderful job. So we have been starting this discussion last year, as personally, and then the fact that we can come and sit with the students talk is incredible, because we can bring the other side of the equation when the student goes out. We can come and challenge and say, like, I have a new problem that might not be explored in the course. Are you interested in that, and so on and so forth. And as an example, one of the guys I'm going to present here, it's fun enough, he was work with us when I was on the other side. We told him to come, go and do the master. Then he did the master in a topic that we were discussing about. And then you see that that interaction is incredibly good. So the work that we are doing, that is trying to bring the industry, and I repeat again, the industry has this responsibility to come to the university and bring ideas and ask challenging questions, so it's essential.
Yeah, I think the graduates coming through these sorts of this program and similar ones is absolutely fantastic. I guess one of the things that is really hard to teach is all of those peripheral skills. So you kind of want to come out with a really strong core plus this ability to learn everything else. And they used to talk about T-shaped individuals that are a little bit of knowledge about everything and a lot about one thing. And then I think the rest one of the pie shaped, you've got to have two things you're really deeply knowledgeable about. But that's sort of the idea you've got is you're entering an industry that kind of knows what data science is now, that probably didn't when most of us got into our careers. And so it's more likely that if you want to be in a specialist role, there'll be a core that's sort of, we need the person to analyze this data set and build this model. There's still, so there's for the larger organizations, the more mature organizations, that's the type of role you want to be ready for, and that requires sort of the depth and the, check the list type of skill set. But still, I would say the majority of opportunity and the sort of people who end up going into data science are often quite entrepreneurial, quite interested in dabbling, and I guess the thing to be working on is how do you get the experience of dabbling and realizing that no data is any good. Actually, when you start with it, you've got to learn to deal with ambiguity. And I often say to my team in the health world that it's all very well to say that data is not good enough to build that model, but at the end of the day, when you see your doctor, they don't get to say, sorry, I don't know what your family history is, therefore I can't give you any advice. Like the context where you have to give advice exists regardless of the quality of the data, and figuring out how to actually integrate that real messiness of real data is really complex. And I think that's a skill set that you can only really get by actually having a bit of experience in more than one area to just go into a few areas. So that's a good experience, I recommend.
I would agree with a lot of those things. I think one of the things I would encourage people to think about is the understanding the inertia of middle management around data science. That you will enter into an industry as pioneers, and you will know a lot more about what is possible and what can be done, and you will be struggling to bring people on your journey with you. So you need to have skills to, I guess, be a bit of an evangelical data scientist in an organisation somewhere, and you may be really lucky that you're surrounded by those people and it's really easy, but a lot of the time you may not be. And it's about getting people on board, slowly reinforcing all of their cognitive biases, bringing them around to the way of thinking where all the skills that you've learned can really add value to the organisation. So it's an amazing industry and it's an amazing discipline to have, but just remember that you're the pioneers of it, and you may not be going into an environment that fully understands it. So that's going to be on you. That's what I would say.
Can we do anything at the university to promote,
Yeah, I think that feedback loop that you talked about, I think just needs to be really tight. You know, so the projects are amazing because you get that real world experience. You can go in and you can learn about you know, the challenges that businesses have got, the time frames that some of them are working on, the under-resourcing that some of them have, and bring that back into your education. So I think tightening up that feedback loop between industry and the academia is essential. And maybe there's other ways, you know, outside of just the projects that can be done to bring that industry knowledge back in.
Yeah, I always feel slightly guilty answering that question because you keep bugging me to take students and the other guys here, and I haven't done it, which is kind of bad. And the reason I haven't done it is because partly the nature of what I'm doing, startups, they are often bones of their ass. There's just no fat to be able to do that because it would take kind of to your point, it takes a chunk of time. But I think generally you guys are doing a really good job of it because you really have tried to work these connections and get and these great talented people to work in the world that we live in. And it's kind of riffing a bit on what the other guys said. I think my original degree was in psychology, which is quite actually the Pearson started in psychology too. I think it's kind of orthogonal to tech in a way. But when you get into the business world, you find influence and is a really important thing because first of all, a lot of businesses don't know what they don't know. When I left IBM and I started just going back to consulting personally, one-to-one with companies, I had to dumb everything down to really simplify it. Because the understanding in the business world of the things that you learn in more rarefied or academic environments, IBM is kind of an analog to universities in a way. It's night and day. Like a lot of businesses have a very shallow understanding, if at all, of what you're doing and the value that you bring. So you do have to be a real evangelist and believer in what you're doing. It's really, really important. And in fact, maybe you guys should have some psychology, parts of what you teach, because my God, my first job in the business community, I ended up, first major one actually, I went overseas and I ran a €100 million plus project, a technical transformation project, unbelievably massive, multinational. And everything I'd learned in psychology, running research programs in the community, was exactly transplantable to that job. So, maybe something like that, but keep hammering people like me too, who are slackers and
at least get them to publicly admit it.
Totally.
Thanks, guys. Maybe we can open it up to the audience. Are there any suggestions from the audience? Perhaps even the students who can tell us what they want more of or less of. Or you want to?
I can just.
Okay. Yeah. Great. Yes.
So I do have a particular suggestion, and that relates to the basic idea that a lot of data science is oriented towards business problems, but we also have social problems. And one of the ones where I think data science has had a remarkable impact that people may not be aware of. In November of 2019, a memorial to the victims of the 1918 pandemic was erected in Wellington. And who unveiled it but Jacinda Ardern? So when COVID hit, she had been looking at a data visualization of the death distribution across communities in the North and South Island. This monument has two segments, and each of the sort of clusters of holes in this sheet metal showed how many people died in each community. So she had this in the top of her mind when she's decided on our Go Hard, Go Early campaign, which has had such remarkable results here in New Zealand. And if academia can keep these kinds of issues as a focus, that students can work on socially significant problems, and I know this is in fact something that's happening particularly in the health space. I think it will have great benefits beyond our business needs and our academic objectives, and impact the whole community.
Yeah. Thanks for that. So we'd be very interested in any projects you'd like to offer.
I was involved in the food trends with Henny.
Oh yeah.
Yeah. So when I worked at So
Yes.
I've already been involved in trying to understand how influenza spreads through the country.
Okay.
Yes, and also bringing interns from the student body to work in the data science commercial setting.
One thing I'd comment about that, because I've done quite a lot of work with government over the last 20 years, is that I totally agree with everything you say. I come from a social psychology background, totally get it. Is that part of the problem with government in New Zealand is it doesn't understand what good looks like in terms of technology and outcomes, I think. And so whenever you propose anything that's socially good, there's not a framework to evaluate it from what is best practice or what does good look like from an outcome point of view. So it's actually very hard, I find, often to get traction with proposing anything that is socially good. But if you can work a business, because this is the neoliberal world we live in, if you can work a business context into a social good, much, much better uptake, unfortunately.
Anybody from the student side? Or you can tell us later. Okay, perhaps moving on to a second question. I mean, it's great to get students into industry and working for them and so on. But one of the questions that actually came up from several of our industry partners almost simultaneously was, how can we support lifelong learning? So especially, of course, in data science, since we're a data science panel. But what does lifelong learning for data scientists look like? So for the whole career and possibly beyond a single company. So how could this look like, and how could we incentivize that?
I guess I want to, more than answer that question, I just sort of want to add to that. So, you know, I know some of the people around this room, and I know that you didn't start as data scientists, that you came from other disciplines, and some of you have reinvented yourselves completely. You know, and also, you know, I made a cynical remark about selling courses and that sort of thing. But one of the things that really interests me is adapting what has been a conventional university model to fit the needs of industry. So we all pretty much recognise now that the days of taking a job when you're 18 years old and staying in that job till you retire are gone. You will need to change careers, and you'll need to change what you do. At the same time, you need to work and you need to have an income, and you can't afford to stop to study full time for long periods of time. So I'm interested in how the model of education should adapt to deal with that reality.
So I can share some of the, I guess, the difficulties that I see when we're trying to recruit people and into data science roles or analytics type roles is the one on, you know, how do you know that person has got the standards that you're going to need and the behaviours that you want from that person. So when you hire engineers, you know, they've got certifications on technology and you can test those objectively, but some of the skills that you have with analytics and data science are a little bit harder to objectively test. You know, it's more of the psychology and the behaviour and things like that. And while you can test technology and the tools that they've had experience with, it's more difficult to test the softer skills. And to me, those are the more valuable ones, because the technology kind of just washes over you over time. But if you are a naturally curious person and you will learn things yourself, those are the people I'm interested in, because they will fill in the gaps and what have you. And you know, I think the way that the university can help with that is by, I guess, keep regularly touching base with those people that are in those industries, and also the people that are not necessarily graduates from a defined course like data science course. It's the people that are self-learners, that they've reached, you know, very high levels of understanding through Kaggle and experimentation and things like that, and you know, and then how do you get those people, I guess, certified to, you know, to use those skills in different industries that they move to. I think I've just asked another question as opposed to answering your question. I'm good like that. So it's more about of recognizing skills or having some sort of framework to recognize attributes or characteristics alongside recognizing technology or technical capability. And I think that the university could actually help with those things, because you're instilling a lot of those behaviours in the students as they come through. But it's also an opportunity to instill those in analysts that may have been, 20 years without a professional degree, but they are already perhaps even more competent than some of the graduates that are coming out because of that industry experience. I think that makes sense. You're nodding, so I'm thinking that makes sense.
Yeah, I think it's a really hard one. When I was at IBM, they really struggled with this culture of lifelong learning inside the organisation, and they ended up implementing this atomisation of qualifications. So you would just take a really big qualification, certification, and break it down into these little disciplines, and it actually gets to be really, really bloody confusing to understand what the hell somebody's got. So I've hired a lot of people over the years, and what I look for is aptitude and ability, kind of what you're talking to there. And you want to see a trajectory, and you want to see an intention, but most of all you want to see, can the person first of all do what they say they can, but are they motivated, are they excited, are they interested in learning a lot more? You're looking for a lot of really intangible things. Goes back to psychology again. But then we always struggled with how you cycle people back into, if this person wants to retrain in data science, and I'd literally just say, go and do Sebastian's course a lot of the time. So I don't know how many did, but it's a really hard thing, and in a way chunking courses down and making them accessible in professional development, making them smaller, very time bound, and potentially, especially if you're coming from industry in, so that you're cycling through it, that it can be linked back to what you're doing in your day-to-day, that's actually really useful. But it's a hard problem to solve, actually.
Yeah, it seems to me that part of this is sort of checking down that module. What are the modules of a data scientist that we're looking for when we hire people or when we build successful teams? And to me, one of the things the university could do is help define those things. And it is broader than the technical question of, there is I need people to know how to code in these languages with these systems. But there's also often the person comes with all that technical expertise, but can they handle an ethics approval to get their hands on data, and do they understand what that even means? So almost saying, here's the checklist, and we're going to do a short course available to the people just for the gaps they've got in their knowledge, because everyone's got some gaps and everyone's already really good at some things, so you kind of want to put something out there. I guess the other thing from a university perspective is you do want to be the standard setter, and the qualification needs to mean something. So you're competing with, we can all get something for free on Coursera or watch the TED Talk or online version of something, so we can always get the information elsewhere. So what is it that university is actually giving? It's a validation of a standard. It's a community around it. So when I know someone's been to a short course here and they've had this particular lecturer, I know they've interacted with people who know what they're talking about and will have challenged them in different ways. And I think the other aspect of it is how do we do it in a way that we can encourage industry to almost start to look to university for defining those standards, and saying, for example, that we would promote people who have had these things checked off. You just called Richard Dean's eye at the back. He's someone who, talk to him later, has done a course in the UK as sort of a data science qualification on the back of another career, and it was a bit more substantial move, I think, in his case. But there are those kind of examples where someone's really wanting to make a career change. But there's also often those I have 2 gaps in my knowledge base, and I really need those short, sharp. I need it to be good enough that my boss will give me a little bit of time off work to study, so that it's not absolutely scrambling in my spare time, but it can't be so much that I'm going to get behind. So it's getting that balance right.
I'm going to take a different spin. I will take from a student point of view. I didn't tell you my background, but I started as a pilot at the Air Force, and I moved to many different places. My PhD was in bioinformatics, trying to understand why you eat chocolate and you have a brain disease. So I think that from a student point of view, you need to be ready to always change, always learn new things, and so on and so forth. So we saw when the students were talking, they are not students anymore, they are in the industry, but they all had that will to learn. And I think that's the only thing that you can do is, at the university where we are trying to do, offer things that allow people to learn new skills. I don't think that is easy. I agree completely with Douglas. It's not an easy thing to solve. Again, I'm going to repeat, the industry has a responsibility to come back and push the university to change. You said already there is no more space for the traditional university. You come, I teach you this thing, so on and so forth. It's not going to go. So from a different spin, it's like, if you want to do this thing that's nowadays is called data science, our time was a different name. I actually started in mathematics or informatics. I don't even remember what's the name that I had my first degree in this area, but you are here, this thing is going to keep moving. It's an important area of our new world, so you need to be ready to learn, and the university, what can do is try to adapt as fast as possible and engage with the industry to go where we are going, because there will be, the change is going to be constant. But at the end, my opinion is our responsibility as students to get there. Can't be university and industry, needs to be the three together working. And that's what we are trying to do here at Excellence.
I think one really important aspect to that is that you as students, if somebody once said this to me and I'd never thought about it before, run your career on the principles that you care about, actually.
Yes.
And that is what will lead you to actually have a really fulfilling career. So the things that interest you and that you believe in, and part of university's job is actually to expose you to as much as possible, so that you, whatever it might be, and you have a passion in whatever it is, you do this course because you're interested in it, and you can pursue that interest through what you're learning here. And that makes you the most effective that you can be in your job, be it in whatever discipline, social, good, business, whatever. To me that seems to be one of the most important things. And the most effective people I've ever worked with come from diverse backgrounds, they've done weird shit in their life, and they are totally principle driven.
Can I just say one thing about that? We had a discussion in the curriculum discussion, and I remember asking this student and say, we don't teach anymore analysis and design at university, please. And I think it was you that said another paper, you said to me that we have that paper, no one takes that. And I think that is the part that I'm talking about, is like we as industry and the university, we need to help people that are coming to go, hey, in reality, if you don't know what design means, you are not going to be able to design a data science model or a drug or anything else. If you don't know a bit of the psychology space and you didn't any knowledge acquisition, you are not going to know how to talk to people, and so on and so forth. So I think that's the role that we need to move of guiding and mentoring. That might be the answer.
So I think I wanted to bring this up in an industry advisory group meeting, but perhaps it's better now. So I mean, we're doing currently the project together, right? So that's really collaboration between industry, the students, the academic advisors. But last year, just before COVID started, we were trying to do a bit more in the sense that, we run our traditional academic courses, but alongside the course, we have 2 or 3 people from industry who actually talk about how the concepts that we use as part of the course within an industry context, about specific technologies that they use to apply and solve the problems, and so on. And that builds up, not only gives it motivation and real world context that motivates the students, but it also builds up the students to be ready to do projects with the people who take part from the industry in those courses. So what I would like to encourage people in our industry advisory group, and if you're not part of this yet, please do, to come and perhaps join something like that, so that you become part of the course and work on this together. And the other aspect I wanted to bring up is that I don't think that we're doing a particularly good job yet in terms of getting success stories out there. I mean, we have success stories within the university, within the program, within an organization, but the actual success stories about these collaborations, what they bring forward, I think they're not out there. And if they're not out there, people don't know that they're basically sitting in the same boat, or they're wanting to try to solve a similar problem, or they look for a similar opportunity. But if they see these success stories, I mean, they find an easier way towards that solution, and at the same time, we're giving more credit to the people who have done these works before, and we just become closer together. So that's just something I think we can also discuss more in the industry advisory group later today. We have one more suggestion.
Add to that, definitely make that an agenda item of that meeting, along with the psychology and design part that we've talked here. That should we actually be introducing a paper or something along those lines? Because as these people are building models that are going to impact human lives with the decisioning that they're going to enable, we really think about the societal element and the human first in the loop, which would always help them, whether they are going to design for a business problem or they're actually thinking about the impact it's going to have on the automated decisioning. So bringing that into the course, I think, would be highly valuable. We somehow can.
And then actually just building on what you guys just said then is, the thing that you really see when you transition into outside of university is frameworks for understanding. Psychology is one baseline framework, and it's a very human-centered one. But when you go into any kind of business context, the thing that is, I don't think you really get educated in, and it's because there's just too much to do. And it gets to what you said about people like us coming in and working alongside courses, is being able to set your understanding of the thing that you do and the frameworks for doing things in a non-academic context. And there's lots and lots of different frameworks. We saw some of them in the presentations earlier. So things like just standard software development life cycles, and how you're working with security models, and how you're working with change, like enacting change in an organisation. There's a lot of this stuff. A lot of businesses in New Zealand do it very, very badly, and it's something that I suppose we can help in that teaching context as well. And it actually really enriches what you learn here, because it actually grounds it in the real practical reality of doing it for an outcome and for a principle and a goal.
Yeah, I was going to reiterate the point about telling good news stories. I think to the point earlier about the modelling that Tepina Martini and others have been involved in, that some of us have been supporting, we have a sort of a chance of a lifetime to talk about how data science has made some social good decisions at an amazing scale. And the reality in health is actually really so difficult to get permission to get access to data, and social license is the term we talk about. Are people generally comfortable with that sort of data sharing? The answer, if you actually ask people, for example, would you share your health data if it would help people with similar conditions? The answer is always yes. But then when you ask a health provider who looks after a data set, can you just share that with me so that I can join it with my data set and help predict what will happen to people? The answer is explicitly no. And so how do we get across the line? The only answer is if society starts saying, we can see the value in this stuff, it's actually making a difference, and therefore I expect that to happen. So I expect when I go to hospital that my data is shared with my GP. It doesn't happen today.
We can put this up as a referendum.
Yeah, well, it's almost, I do think just thinking about going into a career, you're going to have to be evangelists, not just within your organisation of getting data science, but actually, at a larger scale.
Yeah.
Hi guys, thanks for the name drop, Kevin. So I think to pick up on the points there about the kind of how do you keep your career going as a data scientist into the future. You guys are at the point where the technological landscape is evolving incredibly quickly. Like when I went to uni 20 years ago, I didn't have a mobile phone, which had GPUs on board and cameras here, that, there and the other. We're kind of, things are moving on so rapidly. So within where I previously worked, Public Health England, and now within ESR, we have tried to pair up data scientists with our other scientists, our technicians, and show them face-to-face what the rest of the organisation does day to day. And everybody learns, and I think I accept, if I'm not constantly running forward to learn something new every day, every week, every month, every year, then I fall behind. And that can't happen. At this point, New Zealand has a great story to tell in our data modelling. in our genomic sequencing, in actually having a Prime Minister who comes and visits us and asks us questions about particular cases and their particular strain of COVID, and somebody who actually gets it, the point. But industry engagement, we have so many exciting opportunities to tell, and I think that John's question about don't just look at industry as one thing, but look as the whole of society. The presentation we saw from Amazon, I was kind of late because I was having a good chat to the AWS guys and saying, I think that slide's wrong. I don't think you should be presenting to these guys that that there has been $50 billion spent on AI and machine learning and data science. I want to see the answer from that. If you've invested $50 billion, what's the outcome? Because saying data science is sexy is one thing, and saying that AWS have made a load of money out of it is great, but tech and most expensive device in history and all that. But in reality, how can we make our society better? How can we make people live longer? How can we ensure that if and when a vaccine comes, how do we know that that vaccine is safe for our country? And what John says, in the 1918 pandemic, Maori died about 6, 7 or 8 times. The Maori death rate was about 7 or 8 times higher than it was for the Pākehā population. We don't want that to happen. We understand that at the moment there are inequalities in healthcare, in access to housing, and in access to good food. And the type of research that organisations like the Crown Research Institute and DSR do, like the project I was working on before COVID hit, to make New Zealand houses less susceptible to mould, and we've transformed that into a project that looks at image processing to improve lab processes for COVID. There's so much opportunity out there, and don't be drawn just into AWS and the big international names. I do think within New Zealand there are some incredible opportunities, but never expect a career which will stay static. You will have to go back to learn new stuff all the time and push yourself. So that motivation and that excitement is what I certainly look for when I look at graduate CVs or opportunities for internships. But I want you guys to bang on my door and say, hey, look, Richard, find a project for me or a team of 2, 3 or 4 of us guys to kind of come and do something cool with all your big data. It's for all of our gaming.
Just building off that, almost I think one thing, I know we sort of talked a little bit about this, that would be really useful is you guys will have loads and loads of ideas of really amazing things. And if you look at the future of the world, there's a lot of social and environmental problems that need to be solved, and you can't really necessarily rely on other people like governments to solve them for you. So building some sort of entrepreneurship model off the back of this course I think would be invaluable as well, because they're only going to be solved by, smart people doing really interesting things that other people have not thought of before. So that whole issue of diversity and just organic evolution of ideas that can be turned into solutions for problems. If I think of my kids going forward, they love nature, they might be part of a solution to solve problems with the environment, but it has to sort of, I think really the force of that has to come organically from below. And so even trying to fold elements of that into the course would be really useful.
Cool. I also think, sorry, no, Karen, you were first.
All I wanted to add was a little anecdote that industry is looking for the ability to learn now.
Yes.
And I can say this specifically because I'm trying to get a job with AWS, and what did they send me but a link to a book which says the way you manage people is you get them all learning all the time. So there's no more corporate training programs. It's all about getting people who are engaged. And this is, I think, is the key role of the university experience, is the learning how to learn. It's the metacognition that's the most important skill.
You guys do know what COVID stands for, right? It stands for create out of this world value in data.
Did you just make
Okay, anyway, I think we have to wrap up the discussion. I think we're already completely overboard, but it was a great discussion, and I think we follow up on this definitely in the industry advisory group. So I hope to see most of you guys there as well. But we have to, so thanks for the discussion, not just the members, but everyone. And I think we move on now to the student presentations. Thank you.
Shut down after Gareth unplugged. Yeah.
Which one you want?
Should be guessed. It's not detecting.
Okay, hi everyone. My name is Jeff Shi, and I'm one of the students in the Master of Professional Study in Data Science. And it's my privilege to stand here and present you guys about my project. So the title of my project is an explainable and accurate personalized recommendation system for e-learning platform. So before we start look at the motivation of the project, I want to give you guys a little bit of the background of this project. So the company want to reduce the customer churn rate in the upcoming 5 years. The reason behind this is because they want have a steady revenue, but not only have a steady revenue, but also they want to give themselves a buffer to drive the growth. So initial investigation has been carried out show that the more active customer using the product and the most unlikely they're going to be the churn. So with having this background, we have developed our motivation of the project. So first, I want to able to do the customer behavior prediction. Second, we want to have an accurate personalized recommendation system to boost the product usage. And the last thing is we want to able to verify this prediction and the recommendation. So it's time to raise the questions. So first question is how machine learning can help with modeling the customer segmentation versus the customer behaviors. And the second question is how utilize the machine learning model to generate a personalized recommendation system for product team to use. And the third question is how confident we are about to trust our model and prediction. So let's resolve the question one by one. The first is do the prediction job. We want to build the prediction between the customer profile and the customer behaviors. Actually, the machine learning will already have proposed a lot of mechanisms and approach can do that. And particularly, we use random forest to do this prediction. And it's an ensuable approach built on the decision tree and use the majority voting to get the final prediction result. But this bone structure of the model is not always necessarily guarantee you will get the best outcome. So we also propose a few model engineering to improve the model. The first thing we did is called feature filtering. So we can extract the features of feature importance scores from the model and trying to filter out the features which is not important to the model and refit model again. And the second step we do is like sometimes you purely rely on the imputing splitting point for each decision tree might be biased. So what we do is we're going to permute the feature values versus the prediction class and redo a couple of times and we will get empirical distribution. If the mean value of this is like less than 0 negative, then possibly the indication that this is biased. We're going to further reduce this feature from the model. And the third thing we do is called correlation detection. So in a highly dimensional data set, it's very common to see statistically they call the multivariate collinearity. So we're going to trying to find these one features and reduce the other into one cluster and refit model again. So the first three things all about reduce the noisy features and make our model more resilient to do the prediction job. And the last thing we call hyperparameter tuning is going to find the best outcome for the model settings. And then we will able to help us to do the best prediction job. So we can see on the left-hand side, this ROC curve. After we do each steps, the variability of the ROC curve narrow down in a noticeable way, but though we know that we have noticed that the prediction accuracy is not increased that much. So the final model we use for the later on investigation having the 89% of accuracy. This is the model. So we have successfully resolved the first questions. Now it's about how we can build the recommendation system. And we use the feature tweaking algorithm to do this. And the algorithm takes as 4 key components as input. The first is the feature vector X that represent the certain class labels. And second is the chosen model which have derived from the previous slide. And the third one is the cost evaluation function. And the last one is the positive threshold to exclude the infinite tweaking loop. So let's look at one example in a very in one tree. So we have an input feature vector X equals x1, x2, and x3. So x1 is larger than A, x2 is larger than B, and x3 is smaller than C. So it leads to the prediction path as the blue one to the class label 1. So the ultimate goal we want is to convert from class label 1 to 0. What we do is we're going to replace the x3 value as the new value C plus epsilon. Now it's larger than C, so it will lead to the prediction class label as 0. So it's one successful tweak in one tree. So for the higher level, the algorithm we're doing is going to fetch all the possible paths in the forest, not the tree, and then are going to generate those candidate X. And lastly, we're going to use the cost evaluation function to find the optimum, the costless result. So this is the algorithm part. And we can do some experiment, and we're going to grab 2 users in our system and then applying to the algorithm. The algorithm got the result and suggests that user 1 should use a feature called HL tab viewer. And the other user, we suggest that she or he should use the TD stay in folder. So if they start doing these things, the algorithm tells us the most likely we are converting them from the low active status to the active status. So it's from the user perspective. Also, we can run a scale run on the algorithm, and we will get a high level of abstraction of the feature tweaking patterns. So the red one represents the kind of negative tweaking, and the blue one represents the positive tweaking. So let's say if product team want to do a feature enhancement for the next sprint, and then this is a very good reference for you to use, like which feature should be put into the priority and which one should not consider. Or you can see that the most frequent negative tweaking one, there's any room to be increased. So either way, you can work as a good reference. So we have this recommendation system and we have this prediction job. And how well we did this, and should we trust our model? So we use another tool called LAM, aka Local Interval Model Explanation. So it's a tool example. Let's say we haven't classified doing the picture prediction, do a picture classification, and whether it's a wolf or husky. So input data is a wolf, a husky. Unfortunately, our model tells us it's a husky. And why is that? And the LAM can tell us actually on the right-hand side is explanation. So actually it's using the background of the pictures doing the prediction job. So apparently we should not trust this model. So let's look at our experiment. So we have put out data, we have 2 data, one is pre-tweak and one is post-tweak, and applied to the data. And the model, the random forest model tells us before the tweak, and has been classified as low active status. And the next one, after we tweak this data, and then it's been classified as active status. So why is that? In the middle is the explanation part of the LAM. So you can see before we tweak, a lot of features endorse the low active side, and that's why kind of like grade each other, the model prediction and the LAM explanation. So we should trust the model. And after we tweak, see like we increase the highlight tab viewer. So we can see that has dominant impact on active side. So they both grade each other, so we should trust the model. So it's time to do a conclusion. So as a data scientist, I truly believe we can do business insight we can dig in more business insight for the smart decisions. And like we did, firstly, we successfully built the model to build the relation between the customer behaviors versus user profile. And then on top of that, we have proposed a personalized end user engagement that feature tweaking has provided a customized product and promotion solutions for different end users. And last but not least, we can use this as a reference to do customer roadmap guidance. So it's very useful for product engineers and can leverage the business intelligence. So last thing is future work for completion. One is we want to extend our algorithm to the multi-class situation scenarios. And the second one is we want to optimize the weighted cost function. So currently we use very naive Euclidean distance to evaluate which one is the best one, but we always can put the weighted, like which feature is important, we can weight them and get the customized cost function. And last is abstract tuning. So it's a global threshold. We can make it up and make it down and depend on what you get. So you can do another round to see which one is the best outcome you can get for the global threshold. So that's my project. And thank you for listening. And I'm happy to take your questions.
Insights that you've discovered through there, have they been put into practice yet? Have you used them?
So we haven't deployed to the production environment yet, but we proposed a plan that because these first one and the second one, the first one actually is the landing page when customer access to the software. So we just decided to maybe we can do some experimenting to change the landing page for the second one, which is the popular one. Once they land into that, they most likely can be convert from the low status to the active status. So that's the plan to do the A/B testing for the later of this project.
Okay.
Thank you.
Thank you very much.
Do you know where I can find? I don't know how to find it. Oh, here you go. Okay. Hi everyone, my name is Kelson Diogenes and I'm here to present my project, which is entitled Applying Graph Analytics to Fraud Detection in Companies' Office Data. As you may know, Companies' Office is the government official agency that manages the data of companies, New Zealand companies. And the data that they hold, it's data about the contact details, shareholder information, directors, and everything is publicly available through their website. As you can see, that's on the background, that's actually a web page of a company that I searched before. So the goal of this project is to apply graph analytics to see if we can find some fraud in the activities. When I talk about fraud, I'm actually talking about corporate crime. So why am I studying this? This project, corporate crime is a big problem, even in New Zealand, believe it or not. According to the Serious Fraud Office, it's about $10 billion a year of problem. And the type of problems is tax fraud, tax evasion, corruption, money laundering, and so on. And in almost every scenario, what the criminals do, they misuse legal entities, corporate. And to combat that, what the governments do, they try to implement laws like anti-money laundering law, because what they actually do, the whole idea of corporate crime is trying to hide assets that are illegally obtained through crime, through legal channels.
And so they try to disguise those assets. And as part of the legislation, these laws, like in New Zealand, the Act 2009, the regulation that there is in the law is to try to require financial institutions like banks to disclose and identify those beneficial owners, right? So in other words, the people behind those corporations, and that regulation is called Know Your Customer or Customer Due Diligence. So basically, the main question is, can we, by applying graph analytics using the public available companies' office data, can we see if we can find some fraud activities? The keyboard doesn't work. So the methodology that we used, these 5 steps. We've got the traditional ETL, that we extract the data from the company's office API, data service, and the target database we use Neo4j graph database. And the fraud that we covered, like here I'm going to present 3 different fraud scenarios, and we applied pattern matching by using Cypher query language. And this is the end result. We've got the graph model, where the data population on the bottom left, you can see that there are about 8 million nodes, 1.4 million companies, New Zealand companies, and 3.7 million individuals. Those are not unique individuals, of course, because the companies of data doesn't uniquely identify customers. The people behind, the individuals. So you get a lot of duplications. Shareholders, directors, they are the same, but they are just duplicated records because you can't, they don't have a unique identifier for those individuals. So next up, what we did, once we've got the graph ready, so we applied Neo4j data science library to perform these 3 different steps. On the top right, first thing we did, we look at shared addresses. So we applied PageRank on addresses, and we found, for instance, this particular example, this is the top ranked address. It's a single address shared by 1,200 companies. And once we apply the PageRank on addresses, we applied also community detection to identify, the connected, company structures, the connected shareholders, and so on. And on the left, on the bottom left, this is an example of a single community with 36 companies. So with shared addresses, community, then we use that to dedupe the individuals. So what we did, using node similarity on the bottom right, so we applied that functionality to see if we can find what are the individuals, they are actually the same. So in this example, we've got, you can read from here, 16 different individuals. This is the dark green circles, nodes. So all of these nodes, dark green ones, they are actually the same person. And then going back to the question of, okay, who is the beneficial owner? Who is the people behind those organizations? So we run this beneficial ownership pattern, and there is actually a beneficial ownership test that is done. There is actually, beneficial ownership is well defined. In New Zealand Reserve Bank, for instance, they have a guideline that shows exactly the definition that individuals with over 25% of shares, they are actually the beneficial owners of that particular company. So this particular example, if you look at the top company, ABC Limited at the top, the beneficial owner of that company is actually right at the bottom, 3 levels down. So by the way, just a disclosure, all these examples that I'm showing here, the examples are real data, but the data itself has been anonymized, of course, for privacy reasons. So here's the first fraud scenario I'd like to share with you. This is about Phoenix companies. Phoenixing is a very popular fraud activity. And what that means is that you own a company, that company gets in debt, then you liquidated that company, you open up a new one, assets get transferred, and the debt is left behind. This is, again, it's illegal, of course. And as you can see in this particular example, we've got at the top brown nodes. These are insolvent companies, and they're being replaced with two new companies, the red ones at the bottom. And the control was maintained the same, and the trade name is the same as well, so which is illegal. So you can't create a new company by using the same trade name as a failed company. So that's what Phoenixing is about. And you can see that for this particular pattern, we found 15 other occurrences of this activity. Next up is about offshore versus domestic. I mean, this is about, you know, tax haven countries. And what tax haven countries actually mean, these are countries that don't subscribe to those laws about disclosure or beneficial ownership. So these countries, they provide high level of secrecy and usually very low income tax. So that's why it's chosen as preferred location for, you know, incorporating these shell companies. So in this example here, you've got at the top, the yellow node at the top. This is actually located in British Virgin Island, which is a tax haven country. So this particular pattern, we are looking for relationships, ownership relationships between New Zealand companies and companies, offshore companies located on those tax haven countries. And we found 23 other companies within the same, that follow the same pattern. So the last scenario is about money laundering. The idea of money laundering is to transfer money that is acquired from, you know, illegal activities, drug dealer, theft, human trafficking, whatever. And that money, you somehow you convert that money through legal means, like, you know, through legal assets. And that's usually done by using, you know, corporate businesses. And in this particular case, we are looking at all these different scenarios. This particular scenario, all these different businesses that were created within the same time frame. Ideally, we should be looking for, you know, the financials, the bank accounts. We don't have that. But what you can do, because the idea of money laundering is try to, you know, go undetected, under the radar. So what they're trying to do for high volume of money, of course, they try to distribute that, you know, in different accounts in different businesses. There is the step called placement. So what are you trying to do here? We're trying to find, okay, show me all the companies that, you know, individuals who created, registered many companies within a short period of time. In this particular example, so this individual, this is a single individual, by the way, they are all similar to each other. He created 20 companies within a period of 2 months. That's one new company every 3 days. So that in itself is something, you know, it looks pretty fishy to me. And this pattern, it found 22 other individuals with the same sort of scenario. So, of course, I mean, I use the data that is publicly available in the company's office. Ideally, of course, we'd like to integrate this data with other data sets. And that's one for future work, of course. Also, the quality of the data is not great. I mean, the data itself is managed by the companies themselves. If they go in there on the company's own data, they can change whatever they want. So again, address validation, a proper entity resolution, that would be nice, using proper text analytics matching techniques. And also, this particular data that you used was a snapshot. I mean, I extracted this data back in March. Ideally, you should be using a temporal analysis. So every month, analyze, the increase or decrease, whatever the trends over time. So again, that's something that we can do next. And lastly, I used pattern matching as a way of identifying those fraud scenarios. But again, ideally, you should be using a hybrid approach, using machine learning, supervised machine learning, or unsupervised machine learning, like clustering. The problem with supervised machine learning is the lack of labeled data. I mean, you're talking about corporate crime, right? So only those industries like insurance, banking, they do contain that type of scenarios and real data, labeled data. So they ain't gonna make that public anytime soon. And that's pretty much my citation.
What happened next?
I'm gonna ring the police tomorrow and just ask them to investigate. No. Well, next, as I said here, future. I mean, I work for Inland Revenue. Yeah, and I think I've got my own interest, of course, to present this and see if we can use that internally and so on. So yeah, so I work for the government. So yeah, I guess that's fine.
I work for the government. You should have a T-shirt.
So next for me, that'll be that. Yeah.
I noticed my wife's company was in your money laundering network, so I might have to go work.
What's her name again? Okay, thank you.
Great.
Good afternoon, everybody. My name is Jackie. I graduated last year, and I'm very glad to come back to uni and share my master's dissertation with you. My master's dissertation is about product data mapping, and it is an industrial project, and I was working with a company called Vesta. Vesta is an e-commerce company. It collecting the product data from suppliers and retailer, and it does the cleansing and mapping for retailer, and it feeding the product mapping back to retailer. So what is product data? For example, if I want to buy a luggage, so I type on Amazon and search for luggage, and it will give me this one of this product. So this piece of text basically is the product data. It gives you what is the brand of this product, what it normally have a numeric feature, like in this case it's 21-inch, and other features like it's hard side, carry on, and the color is black, and what the name is this product is a suitcase or luggage. So you might think, oh, it's basically just two pieces of text mapping. It's quite simple, but we actually have some problems if we just use the simple algorithm. For example, let's say a few examples. First, it says Convita Manuka Honey UMF 10 plus 250 gram, and Go House Manuka Honey UMF 10 plus 250 gram. maybe most of algorithms will give quite good matching of these two pieces of text. But are they the same thing? No. The second one, Apple iPhone X 64 gig silver, Apple iPhone X 64 gig black, are they the same product? No, because they are different colors. Cookie time cookies chocolate chunk 175 gram, cookie time cookie chocolate chunk 85 gram, are they the same product? No, because they are different sizes. Also, we have like somebody will describe day and night pills, or somebody will describe it as AM and PM tablets. Are they the same thing? Yes. For stainless steel T316 and stainless steel A4, are they the same thing? Yes. And also they use, somebody like use abbreviations, like for this example, is GH the same as good health? Yes. So our problem is some text is extremely similar, but they are not the same product. And some texts are totally different, but they might be the same product. So based on this research problem, we designed two different methods. The first method is based on the approximate string matching. So we collect data from both retailers and suppliers. We apply general pre-processing for both sides of the product data. It's include there's a few steps. So we change all the characters to lowercase. We remove the extra white space, remove all the punctuations, replace the symbols with words, and try to add some weight for the numbers we use. Change the number to the words. And after the pre-processing, we looked up on a synonym list. This list will give us simple mappings, like previous examples, like AM and PM pills match to day and night tablets or something like this. And then we apply we compare the 7 different distance methods to say how our data perform and how this distance will give us, if they will give us better accuracy on the data or on the mapping, or which one is the best for this kind of problems. And at the end, for each retailer's product name, we give them 3 best matchings for the customer, for best test customer, which is the retailer, to pick which is the best. The second method we use is we apply a deep learning method. Similarly, we have retailers and suppliers' product name, and we apply the same general pre-processing approach to both of the data set. And instead of using the synonym list, because it's quite a pain job to collect the synonym list, as well as somebody need to have a bit of knowledge based on certain industrials. So we just generally apply this approximate string matching method to give matching. So we give these results to the users, and the user can make selection. Like, for example, this ABCD, the best match is ABDC. They will say, okay, this is yes, and the rest will be no. Based on this data set, we will generate a training set to train our deep learning model. And our model will give us the same 3 outputs result. And it will go back to the users, and the user can select again, and we can retrain our model, and it's like a circle. So the deep learning method we used in this scenario, we compared the 2 different models. The first model is by LSTM model based on the Manhattan distance. It has embedding layers, and then by LSTM layers, and then it come to the Manhattan distance and give out a similarity score. And the second one is the multiple LSTM 1D CNN model. This model is the same, start with the same embedding, and then go to LSTM and use 1D convolution 1D with different window size, and then merge with max and min pooling and max min pooling, and concatenate them together and finally give us a result. So I would like to show one of the from interesting side of the embedding. We use word-to-vect embedding method, and it convert the words into 300 dimension vectors, and it will the similar. It learn from the training set. The most similar words will have closer distance, and then to visualize this, we put in a 2D dimension, and here we can see that DRO actually the same as Dr. Organic, and these 3 words actually really close to each other. For the 7 different distance algorithms, we also test quite on the different parameters and try to see which parameter can give us better results. For data, so we test on 2 different data sets. The data set 1 is more contain more words kind of descriptions, and the data set 2 contain more like number descriptions. So we can say our algorithm actually perform quite well with different descriptions in text rather, and with the number descriptions, it's give lower accuracy. I just take a example of 3 different distance mapping, and we can see this is the accuracy giving without pre-processing, and these are the result improved a lot with pre-processing. So the pre-processing is very important in this case, and we can see this method is performing good for both data sets. For the deep learning methods, we can see this Manhattan distance by LSTM distance method is performing better than the multiple LSTM 1D CNN method. So based on these experiments, we can conclude that the trigram cosine distance performs well and stable in both datasets. On the in different scenarios, and the Manhattan by LSTM methods perform better than the multiple LSTM 1D CNN method. So in this project, we designed we used two different methods and designed for the product data mapping, and this can be applied on the different data set in different industries. The limitation is the correct matching rate for the first method is highly dependent on the synonym list. If they give better matching in the synonym lists, and this method will give higher accuracy rates. But this approach runs faster, and the deep learning method need big training data sets, and also every time it takes time to retrain the model and learn the outputs from the users. For future work, we need to pre-build the synonym list, and we can test do some further experiment based on different parameters, or try different machine learning models and see what the performance is. And also we need to deploy this method and with Vesta's website. Thank you.
Any questions?
After this project, did you deliver the mapping data to the company?
Yes.
And from the initiative to the deliverable, how long did it take?
So from the beginning of this project, because it took me 2 papers in the first semester and the second semester, so it's about 8 months. Yeah.
Okay. Well, again, thanks everyone. That's not quite it. So there's still food outside, in particular cake. And then we have our industry advisory group meeting. I think we can start at 1:45. So if you're interested in joining that meeting, please do come along. Okay. Otherwise, thanks again for being here, supporting us, and yeah, I hope to see you again, and hopefully getting some interesting projects from the industry people. Thank you.